You are listening to Python for Software Development, a guided journey. Subscribe to keep up to date on our latest audiobooks. Python for Software Development, a guided journey. Chapter 1, Introduction, Your Journey into Python. 1.1, Welcome to the world of Python software development. Imagine yourself as an architect, standing before a vast, untouched landscape. You have ideas, blueprints, and a vision for structures that could simplify lives, entertain, or connect people across the globe. But to build these structures, you need the right tools, the right materials, and a clear understanding of fundamental engineering principles. Learning to code, specifically to become a software developer, is very much like becoming that architect. You have ideas for applications, scripts, or systems that can automate tasks, analyze data, power websites, or even control robots. Python, in this analogy, is your versatile toolkit, a powerful, yet surprisingly approachable, set of instruments that can bring almost any digital vision to life. Perhaps you've tried to learn programming before, wading through fragmented online tutorials or complex documentation that felt more like a maze than a roadmap. It can be overwhelming. Concepts like variables, loops, and objects can feel abstract, leaving you wondering how they ever combine to create something truly useful. If that resonates, you're not alone. Many aspiring developers face this initial hurdle. A lack of structured guidance that connects the individual building blocks to the grand vision of software development. This book is designed to be your comprehensive guide through that landscape. It's not just about teaching you Python syntax. It's about teaching you to think like a developer. It will equip you with essential principles, best practices, and practical skills, all while using Python as our primary language. Think of this book as a guided journey, moving from foundational concepts to building real, albeit simple, applications. Before we dive in, let's take a quick look at where Python came from. In the late 1980s, a Dutch programmer named Guido van Rossum began working on Python as a hobby programming project, intending to create a successor to the ABC language, which was designed for teaching. He sought to create a language that was easy to read, simple to write, and highly extensible. He named it after the British comedy troupe Monty Python's Flying Circus, reflecting his desire for a fun and approachable language. Little did he know, his hobby would evolve into one of the most widely used and beloved programming languages in the world, powering everything from innovative startups to industrial giants. And now, you're about to join that journey. 1.2 Why Python? The power and versatility. In the vast ecosystem of programming languages, why choose Python as your primary tool for software development? The answer lies in its remarkable combination of power, versatility, and readability. Versatility. Python is often called a Swiss Army knife of programming languages, and for good reason. It's not confined to a single domain. With Python, you can build websites. Frameworks like Django and Flask power some of the world's most popular sites. Analyze data and drive machine learning. It's the go-to language for data scientists, statisticians, and AI researchers, thanks to libraries like Pandas, NumPy, and TensorFlow. Automate tasks. From simple scripts to complex automation workflows, Python can simplify repetitive processes on your computer. Develop desktop applications. While less common than web, Python can be used for graphical user interfaces. Work with cloud infrastructure. Many cloud services offer Python SDKs for automation and management. And much, much more. From scientific computing to game development, bioinformatics to hardware interaction, Python seems to be everywhere. Readability. Python's design philosophy emphasizes code readability and simplicity. Its syntax is often described as feeling very natural, almost like reading plain English. This makes it significantly easier for beginners to pick up and for experienced developers to understand and maintain large code bases. Unlike some other languages that rely heavily on curly braces and semicolons, Python uses indentation to define code blocks, which enforces good coding habits from the start. Large community and ecosystem. When you learn Python, you're not alone. Python boasts one of the largest and most active programming communities in the world. This means an abundance of online resources, tutorials, and forums like Stack Overflow, where you can find answers to almost any question. A massive collection of pre-written code and tools, often called libraries or packages, available through the Python Package Index, PyPy. This means you rarely have to reinvent the wheel. Someone has likely already solved a problem you're facing, and you can simply use their solution. Constant innovation and improvement. The language and its tools are continuously evolving, driven by a global network of open-source contributors. High demand. Given its versatility and ease of use, Python skills are highly sought after in the job market across various industries. Learning Python opens doors to roles in web development, data science, cybersecurity, automation engineering, and many others. In essence, Python is powerful enough to tackle complex problems, yet simple enough to get started quickly. These qualities make it an ideal language for anyone embarking on a software development journey. 1.3 Who is this book for? This book is primarily crafted for the aspiring software developer, someone who has little to no prior programming experience, or perhaps has dabbled, but is looking for a more structured, comprehensive learning path. You might be a complete beginner taking your very first steps into the world of code. Don't worry, we start from the absolute basics. Someone looking to switch careers into a tech-related role. Python is an excellent entry point, and this book will provide you with a solid foundation. A student needing a clear, practical guide to supplement coursework or learn a powerful new skill. A professional in another field, like marketing, finance, or research, who wants to automate repetitive tasks, analyze data, or build small tools to improve their workflow. A programmer with experience in another language, like JavaScript or C++, who wants to learn Python specifically for software development, understanding its unique idioms and ecosystem. You don't need any special qualifications to start this journey, just a computer, an internet connection, and a willingness to learn and experiment. We assume no prior knowledge of Python or advanced computer science concepts. Everything will be explained clearly and step by step. 1.4 A roadmap for your journey, what you'll learn. This book is organized as a progressive learning path, building your skills chapter by chapter. Here's a brief overview of the terrain we'll cover. Setting the stage. We'll begin by getting your computer ready for Python development, installing the necessary tools, and writing your very first program. The building blocks. You'll learn Python's fundamental syntax, how to work with different types of data, like numbers and text, how to store information in variables, and perform basic operations. Organizing information. We'll explore Python's powerful built-in data structures, such as lists, tuples, sets, and dictionaries, which allow you to manage collections of data efficiently. Making decisions and repeating actions. You'll master control flow concepts, using if-else statements to make your programs intelligent and loops to perform repetitive tasks. Building reusable code. We'll dive into functions, showing you how to write modular blocks of code that can be called upon whenever needed, making your programs organized and efficient. Thinking in objects. You'll be introduced to the powerful concept of object-oriented programming, OOP, in Python, learning how to design programs around objects that model real-world entities. Leveraging the ecosystem. We'll explore Python's vast ecosystem of modules and packages, teaching you how to use pre-built tools to accelerate your development. You'll learn how to manage these external tools gracefully with virtual environments. Robust and reliable code. Software development isn't just about writing code, it's about writing good code. We'll cover essential skills like error handling to make your programs resilient and debugging techniques to fix issues when they arise. Working with data. You'll learn how to interact with files, enabling your programs to read from and write data to your computer, including common formats like CSV and JSON. Building practical applications. We'll tie everything together with practical mini-projects, demonstrating how you can apply your newfound skills to create functional tools, from command-line utilities to interacting with web services. You'll even get a conceptual introduction to version control with Git, a crucial skill for any developer. Best practices and beyond. Finally, we'll discuss conventions for writing clean, readable, and maintainable Python code and point you towards the exciting next steps in your development journey, whether that's web development, data science, or specialized automation. Each chapter is designed to build logically on the last, gradually expanding your toolkit and confidence as a Python software developer. 1.5 How to use this book effectively. This book is designed to be a hands-on experience. Programming is a practical skill you learn by doing. For print readers, type, don't copy-paste. When you encounter code examples, resist the urge to simply copy-paste them. Take the time to type them out yourself. This builds muscle memory, helps you internalize syntax, and makes you more likely to catch your own typos, which is a key part of learning. Experiment. Once you've typed out an example, don't just move on. Change a variable, add a line, see what happens. Break the code deliberately to understand error messages. This experimentation is crucial for developing an intuitive understanding of how Python works. Do the try-it-yourself exercises. Each chapter will end with exercises designed to solidify your understanding of the concepts introduced. These are your practice ground. The more you do, the stronger your skills will become. Refer to the online resources. We will provide accompanying code snippets and supplementary materials online. Think of them as your training wheels or a safety net if you get stuck. For audiobook listeners, this book uses a unique approach to make the learning experience effective for audio. When we discuss code, I will describe what it does, why it's important, and how it looks conceptually. I will emphasize the structure and logic of the code rather than reading out long lines of text character by character. Pause and code. Think of me as your guide talking you through the concepts. When an example or concept involves code, I will encourage you to pause the audio, open your code editor, and type out the examples or complete the exercises yourself. Visual companions. A companion website or downloadable resource will be available containing all the code snippets, exercises, and relevant diagrams. This allows you to follow along visually while listening to the explanations, seamlessly transitioning between listening and active coding. Focus on understanding. Your goal as an audio listener is to grasp the logic and purpose of the code I describe. Don't strive to memorize the exact syntax from my spoken words. Instead, understand the principle, then switch to your code editor to implement it, referring to the companion materials as needed. Regardless of how you consume this book, remember that learning to program takes patience, persistence, and practice. You will encounter errors, every developer does. Embrace them as learning opportunities. Celebrate your small victories. Your journey into Python software development begins now. Let's get started. Chapter 2, Getting Started. Setting up your development environment. 2.1, The Developer's Home Base. What you need. Before we can start writing our digital creations, we need to set up our personal workshop, what developers call a development environment. Think of it like a carpenter needing a workbench, a set of saws, hammers, and measuring tapes before they can build furniture, or a painter needing an easel, brushes, and paints before they can create a masterpiece. Without the right tools, even the most brilliant ideas remain just that, ideas. A well-configured development environment is crucial for several reasons. Productivity. It provides features like code completion, syntax highlighting, and error checking, which speed up your coding process. Organization. It helps keep your projects separate and their dependencies clean, preventing conflicts. Debugging. When things go wrong, and they will, a good setup includes tools to help you find and fix errors efficiently. At its core, a Python development environment requires just two main components: the Python interpreter. This is the program that reads and executes your Python code. Without it, your computer won't understand the instructions you write in Python. A text editor or integrated development environment, IDE. This is where you will write, edit, and save your Python code. It's like your digital notebook optimized for programming. We'll walk through installing both of these, step by step, for different operating systems. 2.2, Installing Python 3. First things first, let's get the Python interpreter installed. It's important to note that throughout this book, we will be using Python 3. If you've heard of Python 2, understand that it is now officially retired and not maintained, so we'll stick with the modern and actively developed Python 3. Let's go through the installation process for Windows, Mac OS, and Linux. Choose the section relevant to your operating system. 2.2.1 Windows Installation. Download, open your web browser and go to the official Python website, python.org/downloads/. Look for the latest stable release of Python 3, e.g., Python 3.10x, 3.11x. Click on the Download Python button for Windows. Run the installer. Once the download is complete, locate the downloaded executable file. It will typically be named something like Python 3.10, XAMD64, exe, and double-click it to run the installer. Crucial step. Add Python to path. In the very first installer window, you will see a checkbox at the bottom that says Add Python to path. It is absolutely crucial that you check this box. This step makes it possible for you to run Python commands from any location in your command, prompt, or PowerShell. If you forget to check this, you might have difficulties later. Install now. After checking the path option, click Install now. The installer will proceed to copy the necessary files to your computer. Completion. Once the installation finishes, you might see an option to disable path length limit. It's generally safe to click this, especially if you plan on having many Python projects or long file paths. Then close the installer. Verify installation. Open your command prompt or PowerShell. You can typically do this by typing cmd or PowerShell in the Windows search bar and pressing Enter. In the command window, type the following command and press Enter. Python version. You should see the installed Python version appear, e.g., Python 3.10.7. If you see an error like Python is not recognized as an internal or external command, it usually means you forgot to check the Add Python to Path box. You might need to reinstall Python and ensure that box is checked, or manually configure your system's path variable, which is a bit more advanced. Also, verify the package installer for Python, pip version. You should see an output similar to pip 21.3.1 from. This confirms pip, Python's package manager, is also installed and ready. 2.2.2 macOS installation. macOS often comes with a version of Python pre-installed, but it's usually an older Python 2x or a system-specific Python 3 not intended for general development. For consistency and ease of management, we recommend installing Python 3 using Homebrew, a popular package manager for macOS. Install Homebrew if you don't have it. Open your terminal application. You can find it in Applications Utilities or by searching with Spotlight. Paste the following command and press Enter. bin bash c curl fssl https raw.githubusercontent.com/homebrew/install/head/install sh. Follow the on-screen instructions, which might include entering your password. This process can take a few minutes. Install Python 3 with Homebrew. Once Homebrew is installed, simply type the following in your terminal and press Enter. Brew install Python. Homebrew will download and install the latest stable version of Python 3, along with pip. Verify installation. After the installation completes, type the following in your terminal, Python 3 version. You should see the installed Python 3 version, e.g., Python 3.10.7. Notice we use Python 3 instead of Python to explicitly call the Homebrew installed version, avoiding conflicts with any system-installed Python 2. Also verify pip. Pip 3 version. You should see output indicating pip along with its version. 2.2.3 Linux installation. Most Linux distributions come with Python pre-installed. However, like macOS, it might be an older Python 2x or a system-specific Python 3. It's best to install the latest Python 3 and its associated pip using your distribution's package manager. For Debian/Ubuntu-based distributions, e.g. Ubuntu Mint, sudo apt update, sudo apt install Python 3, Python 3 pip. For Fedora CentOS RHEL-based distributions, sudo dnf install Python 3, Python 3 pip. Or for older CentOS RHEL, sudo yum install Python 3, Python 3 pip. For Arch Linux, sudo pacman s python pip. Verify installation. After running the appropriate commands, verify the installations in your terminal. Python 3 version. Pip 3 version. You should see the installed Python 3 and pip versions. If your system defaults to Python or pip referring to Python 3, great. Otherwise, always use Python 3 and pip 3 to ensure you're working with the correct version. 2.3 Choosing your workspace. IDEs and text editors. Now that Python is installed, you need a place to write your code. This is where text editors and integrated development environments, IDEs, come in. 2.3.1 Text editors, simple and lightweight. A simple text editor is like a basic notepad for code. They offer features like syntax highlighting, coloring code keywords to make them easier to read, and basic indentation help. They are generally lightweight and quick to open. Visual Studio Code, VS Code. This is highly recommended for beginners and experienced developers alike. It's free, open source, and incredibly powerful despite being classified as a text editor. VS Code is extensible with a vast marketplace of plugins and themes, turning it into a near IDE experience. It has excellent Python support built-in and via extensions. Installation. Download from code.visualstudio.com. The installation process is straightforward for all operating systems. Key features for Python: syntax highlighting, IntelliSense, smart code completion, debugging tools, terminal integration, Git integration, Sublime Text or Atom. Other popular choices that offer similar basic functionality but are less extensible for full development. For the purpose of this book, we highly recommend Visual Studio Code due to its versatility, excellent Python support, and beginner friendliness. 2.3.2 Integrated Development Environments, IDEs, powerful tools. IDEs are all-in-one software suites that combine a text editor with a wealth of powerful developer tools like advanced debugging, refactoring tools, project management, and deep integration with version control systems. They are typically heavier than text editors, but provide a more streamlined and productive environment for larger, more complex projects. PyCharm Community Edition. This is one of the most popular and robust IDEs specifically designed for Python development. The Community Edition is free and open source, offering many powerful features. Installation. Download the community version from jetbrains.com/pycharm/download. The installation is guided. Key features: smart code assistance, on-the-fly error checking, powerful debugger, virtual environment management, excellent project structuring tools. When to use which? Start with VS Code. If you are a complete beginner, VS Code is a fantastic starting point. It offers enough features to be productive without overwhelming you, and you can add more functionality as you grow. Move to PyCharm for larger projects. As your projects become more complex and you start working with larger code bases, PyCharm's advanced features can significantly boost your efficiency. Many professional Python developers rely on it. For this book, screenshots and instructions will primarily be generic or adaptable to both VS Code and PyCharm. You can pick either, but having one installed is essential. 2.4 The magic of virtual environments. Now that you have Python and a code editor installed, there's one more crucial tool for your workshop: virtual environments. This might sound complex, but it's a simple concept that will save you a lot of headaches in the long run. Imagine you're a chef working on several different dishes. One recipe requires a very specific brand of flour, while another needs a different, older brand. If you just dump all your ingredients into one giant pantry, you might accidentally mix them up or run out of the specific one you need. In Python, programs often rely on external packages or libraries, collections of pre-written code. These packages have versions, and different projects might require different versions of the same package. If you install all packages globally on your system, you could run into dependency hell, a situation where one project needs an older version of a package, while another needs a newer version, and they conflict with each other. A virtual environment solves this by creating an isolated mini Python installation for each project. It's like giving each project its own clean room with its own set of ingredients, packages, that are completely separate from other projects and your system's global Python installation. 2.4.1 Using Venv, Python's built-in tool. Python comes with a built-in module called Venv, short for Virtual Environment, that makes this easy. Let's create your first virtual environment. First, open your terminal command prompt, PowerShell, terminal, or the integrated terminal in VS Code/PyCharm. Navigate to your project directory. It's a good practice to create a dedicated folder for your new project. For instance, you could create a folder named My First Python Project. Use the cd change directory command. Hash for Windows, mkdir My First Python Project. cd My First Python Project. Hash for Mac OS Linux, mkdir My First Python Project. cd My First Python Project. Create the virtual environment. Once inside your project folder, run the following command. We'll call our virtual environment miprojectenv, but you can name it anything, though venv or venv are common conventions. Python mvenv miprojectenv. On Mac OS Linux, if Python points to Python 2, use Python 3 mvenv miprojectenv. This command creates a new directory, e.g. miprojectenv, inside your project folder. This directory contains a copy of the Python interpreter, pip, and other supporting files specific to this environment. Activate the virtual environment. This step changes your terminal's context so that any Python commands you run will use the Python interpreter and packages from your virtual environment, not the global ones. On Mac OS Linux, source miprojectenv/bin/activate. On Windows, command prompt, miprojectenv \scripts \activate bat. On Windows PowerShell, \miprojectenv \scripts \activate ps1. After activation, you'll usually see the name of your virtual environment, e.g., miprojectenv, in parentheses at the beginning of your terminal prompt. This indicates that the virtual environment is active. To deactivate a virtual environment when you're done working on a project, simply type deactivate. The miprojectenv prefix will disappear from your prompt. 2.4.2 Introducing pip, Python's package installer. Within your active virtual environment, you'll use pip, which recursively stands for pip installs packages, to install external libraries specific to that environment. For example, to install a popular library called requests for making web requests, which we'll use later in the book, you would run pip install requests. This command downloads the requests library and its dependencies and installs them only within your currently active virtual environment. Your other Python projects, in their own virtual environments, remain unaffected. To see what packages are installed in your current virtual environment, you can use pip freeze. This command will list all installed packages and their versions, which is useful for debugging or sharing project dependencies. 2.5 Your first Python program. Hello world. You've set up your tools and your workspace is ready. Now comes the exciting part, writing your very first Python program. This is a traditional rite of passage for all programmers. Let's write a program that simply prints "Hello, world" to your screen. Create a project folder. If you haven't already, create a dedicated folder for this project. Let's call it HelloProject. mkdir HelloProject. cd HelloProject. Create and activate a virtual environment. Inside HelloProject, create and activate a virtual environment. We'll name it venv, a very common convention. Python mvenv venv. Hash then activate it based on your OS. See section 2.4.1. Hash example for Mac OS Linux. Source venv/bin/activate. Your terminal prompt should now show venv. Open your editor. Open your chosen text editor or IDE, VS Code, or PyCharm, and open the HelloProject folder. Most editors have a File, Open Folder option. Create a new file. Inside your HelloProject folder, create a new file and name it HelloPy. The Py extension tells the operating system and your editor that this is a Python file. Write the code. In the HelloPy file, type the following single line of code. Print hello world. Verbal explanation for audio. Imagine a single line of code in our HelloPy file. It starts with the word print, followed immediately by an opening parenthesis. Inside these parentheses, we have a single quote, then the words hello, world, with an exclamation mark, followed by another single quote, and finally, a closing parenthesis. This print instruction tells Python to display whatever is inside the parentheses on your screen. The single quotes indicate that hello, world is a sequence of characters known as a string. Save the file, save the HelloPy file. File save or Ctrl+S/CMD+S. Run the program, go back to your terminal, ensuring your virtual environment, venv, is still active and that you are in the HelloProject directory. Now type the following command and press enter. Python hello py. Expected output, hello world. Congratulations! You've just written and successfully run your first Python program. This might seem like a small step, but it's a huge milestone. You've installed Python, set up your development environment, created a project, and executed code. This is the fundamental workflow for almost everything you'll do in software development. Try it yourself. If you haven't already, make sure Python 3 and a code editor, like VS Code or PyCharm Community, are installed on your system. Create a new folder for a new project, perhaps named MyFirstry. Navigate into that folder using your terminal. Create and activate a new virtual environment inside MyFirstry. Open your code editor to the MyFirstry folder. Create a new file called mynamepy. In mynamepy, write a line of code that prints your name. For example, print "my name is your name" here. Make sure to put your name inside single or double quotes. Save the file. Go back to your terminal with the virtual environment active and in the correct directory and run your mynamepy script. 10. Experiment. Try printing a short phrase. Try printing a number like print 123. Notice how numbers don't need quotes because they are a different type of data. This hands-on work is crucial for building confidence and understanding. In the next chapter, we'll dive deeper into the fundamental building blocks of Python, starting with variables and basic data types. Chapter 3, Python Fundamentals, the building blocks of code. In the previous chapter, you successfully set up your development environment and ran your first Python program. That "hello, world" moment was significant because it showed you how to get Python to execute instructions. Now, it's time to understand the language itself, the fundamental concepts that make up almost every program you'll ever write. Think of these fundamentals as the basic vocabulary and grammar of Python. Just as you need letters to form words and words to form sentences, you need these core concepts to build meaningful programs. 3.1 Variables. Naming your data. Imagine you have a bunch of pieces of information that your program needs to remember and work with, maybe numbers, names, or true-false statements. Instead of just having raw data floating around, which would be incredibly messy, you want to store them in named containers. In programming, these named containers are called variables. Think of a variable as a labeled box. You put a piece of data inside the box, and you give the box a name. Whenever you need that data, you just refer to the box by its name. In Python, creating a variable and putting data inside it, this is called assignment, is straightforward. For print, username equals Alice. Userage equals 30. Istudent equals true. Verbal explanation for audio. To create a variable, you choose a name for your data, then type an equals sign, and then the actual data itself. For instance, to store someone's name, you could say, the variable name is username, then equals, and then the word Alice enclosed in double quotes. For an age, you would say, userage equals, then the number 30. For a true or false statement, you could have istudent equals, then the word true. Once you've assigned a value to a variable, you can use its name to access the data it holds. For print, print username, print userage, print istudent, verbal explanation for audio. To display the content of a variable, you use the print function we learned in Chapter 2, but instead of putting text inside quotes, you put the variable's name directly inside the parentheses. So to see the user's name, you type print username. 3.1.1 Variable Naming Rules and Conventions. While you have flexibility in naming variables, there are rules and widely accepted conventions. Rules must follow. Variable names can contain letters, AZ, numbers 0 to 9, and underscores. They cannot start with a number. For example, one st name is invalid. They cannot contain spaces. Use underscores instead, e.g., username, not username. They cannot be Python's reserved keywords, words that have special meaning to Python, such as if, else, while, for, print. Your editor will usually highlight these. Conventions should follow for readability following PEP8. Use snake case. Variable names should be lowercase, with words separated by underscores, e.g., first name, total price. This is Python's standard style, known as PEP8. Be descriptive. Choose names that clearly indicate the variable's purpose. A equals 10 is less clear than age equals 10. Avoid single letters mostly. While x equals 5 is technically fine, count equals 5 is much more understandable. Single letters are generally okay for temporary loop variables like I or j. Reassignment. Changing a variable's value. Variables are called variables because their values can vary or change. You can reassign a new value to an existing variable at any time. For print, score equals 100. Hash print score hash output 100. Hash score equals 150 hash. Reassign a new value. Hash print score hash output 150. Verbal explanation for audio. First, you assign the number 100 to a variable called score. If you print score, you get 100. Later, you can assign the number 150 to the same variable, score. Now, if you print score again, you'll see 150. The old value is simply forgotten. 3.2 data types. What kind of information? Python is a dynamically typed language, meaning you don't explicitly declare a variable's type when you create it. Python automatically figures out the type of data you're storing. However, understanding data types is crucial because they determine what operations you can perform on that data. You wouldn't add words together, and you wouldn't connect numbers with a hyphen, right? Python has several fundamental built-in data types. 3.2.1 Numbers. Numbers are precisely what you'd expect. Numerical values. Integers int, whole numbers positive or negative without a decimal point. Examples, 5 minus 10, 0, 1000. In audio, an integer is a whole number like 5 or minus 10. Floating point numbers float. Numbers with a decimal point representing real numbers. Examples, 3.14 minus 0.5, 2.0. Even if it's a whole number, if it has a decimal point, it's a float. In audio, a float is a number with a decimal point, like 3.14 or minus 0.5. Python can handle very large integers, limited only by memory, and floats with high precision. 3.2.2 Strings. Strings are sequences of characters. They are used to represent text. In Python, you can define strings using single quotes, double quotes, or even triple quotes, or a for multi-line strings. For print, single quote string equals hello Python. Double quote string equals Python is fun. Multi-line string equals this is a multi-line string. Verbal explanation for audio. A string is usually text like hello Python. You can enclose it in single quotes, double quotes, or even triple quotes if you want your text to span multiple lines. Basic string operations. Concatenation, plus. Joining two or more strings together. Hash for print, hash greeting equals hello. Hash name equals Alice. Hash full message equals greeting plus name plus. Hash print full message hash output, hello Alice. Verbal explanation for audio. If you have a variable greeting that says hello and a variable name that says Alice, you can combine them using the plus sign. For example, full message equals greeting plus a comma and a space inside quotes, plus name, plus an exclamation mark inside quotes. This would result in hello, Alice. Repetition, repeating a string multiple times. Hash for print, hash stars 5. Hash print stars hash output. Verbal explanation for audio. You can repeat a string by multiplying it by a number. For example, stars equals the asterisk character inside quotes, multiplied by 5. This would create 5 asterisks. F-strings, formatted string literals. A modern and often preferred way to embed variables directly into strings is using F-strings, available in Python 3.6+. You prefix the string with F or F, and then you can place variable names directly inside curly braces within the string. Python will automatically replace them with their values. For print, item equals laptop, price equals 1200, message equals F the item costs price. Hash print message hash output. The laptop costs $1,200. Verbal explanation for audio. Let's say you have a variable item with the value laptop and a variable price with the value 1200. To create a sentence like, the laptop costs $1,200, you can use an F-string. You write the letter F immediately before the opening quote of your string. Then, inside the string, wherever you want to insert a variable, you put the variable's name inside curly braces. So, it would look like this. F then the opening quote, then the space, then curly brace item curly brace, then space costs, then curly brace price curly brace, then a period, then the closing quote. This is a very clean way to combine text and variable values. 3.2.3 Booleans, bool. Booleans represent truth values. They can only be one of two special values, true or false. Note the capital T and F. Python is case sensitive. They are fundamental for making decisions in your code. For print, isRunning equals true. Finish at task equals false. Verbal explanation for audio. A Boolean can either be true or false. For example, isRunning could be true or finish at task could be false. These are used constantly when your program needs to make decisions. 3.2.4 None type. None type. None is a special constant in Python that represents the absence of a value or a null value. It's often used to indicate that a variable has not been assigned anything yet, or that a function doesn't return anything meaningful. For print, result equals none. Hash print result hash output, none. Verbal explanation for audio. None is a special Python value that means no value. You might assign none to a variable to indicate it's empty, or print it to see its special none value. 3.3 Operators, actions on data. Operators are special symbols that perform operations on values and variables. They allow you to manipulate data to get new results. 3.3.1 Arithmetic operators. These are for performing mathematical calculations. Plus, addition, 5 plus 3 results in 8. Subtraction, 10 4 results in 6. Multiplication, 2 6 results in 12. Slash division, 10 slash 3 results in 3.333, always returns a float. Percent modulo, returns the remainder of a division. 10% 3 results in 1 because 10 divided by 3 is 3 with a remainder of 1. Useful for checking even odd numbers, number percent 2 equals 0. Exponentiation, raises the first number to the power of the second. 2 3 results in 8, 2 multiplied by itself 3 times. Floor division, performs division and returns the integer part of the result, discarding any fractional part. 10 3 results in 3. Order of operations. Just like in mathematics, Python follows the standard order of operations, parentheses, exponents, multiplication and division, addition and subtraction, PEMDAS, BODMAS. For print, calculation equals 5 plus 2, 3 10 slash 2. Hash print calculation hash output, 16.0. Verbal explanation for audio. Consider the calculation. Open parentheses 5 plus 2 close parentheses, multiplied by 3, minus 10 divided by 2. Python follows standard math rules. 5 plus 2 is 7, 10 divided by 2 is 5. So, it becomes 7 multiplied by 3 minus 5, 7 multiplied by 3 is 21. Finally, 21 minus 5 is 16. The result for calculation would be 16.0 because divisions often result in floats. 3.3.2 Comparison operators. These operators compare two values and always return a Boolean true or false. Equal to, 5 equals 5 is true, 5 equals 6 is false. Equals not equal to, hello equals world is true. Greater than 10 5 is true. Less than 3 7 is true. Equals greater than or equal to, 5 equals 5 is true. Less or equal less than or equal to. 4 less or equal 3 is false. For print, age equals 25. Canvote equals age equals 18. Hash print canvote hash output, true. Verbal explanation for audio. If age is 25, and you define canvote as age greater than or equal to 18, then canvote will be true. 3.3.3 Logical operators. These operators combine Boolean expressions and also return a Boolean result, true or false. And returns true if both operands are true. True and true is true. True and false is false. Or returns true if at least one operand is true. True or false is true. False or false is false. Not to. Reverses the Boolean value of the operand. Not true is false. Not false is true. For print, hastigit equals true. Isadalt equals true. Caninter equals hastigit and isadalt. Hash print caninter hash output. True. Israining equals true. Hasumbrella equals false. Neatsumbrella equals israining and not hasumbrella. Hash print neatsumbrella hash output, true. Verbal explanation for audio. If you have a hastigit variable set to true and an isadult variable also set to true, then the combination hasTicket and isadult will result in true. If isRaining is true and hasUmbrella is false, then isRaining and not hasUmbrella would be true, meaning you need an umbrella because it's raining and you don't have one. 3.3.4 Assignment Operators. You've already used the basic assignment operator equals. There are also shorthand assignment operators that combine an arithmetic operation with assignment. Plus equals add and assign. X plus equals 5 is equivalent to x equals x plus 5. Equals subtract and assign. X equals 2 is equivalent to x equals x, 2. Equals multiply and assign. X equals 3 is equivalent to x equals x, 3. Divide and assign. X slash equals 4 is equivalent to x equals x slash 4. And so on for percent equals equals. For print, counter equals 10. Hash counter plus equals 5 hash counter becomes 15. Print counter. Verbal explanation for audio. If counter starts at 10 and you write counter plus equals 5, this means add 5 to the current value of counter and then assign the result back to counter. So counter would become 15. 3.4 Basic input and output beyond Hello World. We used print in Hello World. It's your primary way to display information to the user or for debugging. Print revisited. You can print multiple items separated by commas. Print will automatically put a space between them. By default, print adds a new line at the end. You can change this behavior with the end argument. You can change the separator between items with the sep argument. Hash for print, hash print, your score is 95 points. Hash output, your score is 95 points. Hash print, line 1, end equals. Hash print, line 2, hash output, line 1, line 2. Hash print, apple, banana, cherry, sep equals. Hash output, apple, banana, cherry. Verbal explanation for audio. You can print multiple items by separating them with commas. Print, your score is 95 points. Would show all these items on one line. By default, print moves to the next line. You can make it stay on the same line if you add end equals a space inside quotes to the print function's parentheses. You can also control what separates items. For example, print, apple, banana, cherry, sep equals, and a space would print apple, banana, cherry. Input, getting user input. This function waits for the user to type something into the console and press enter. Whatever the user types is returned as a string. Hash for print, hash username equals input. What is your name? Hash print hello, username. Verbal explanation for audio. To get input from the user, you use input. Inside its parentheses, you put a prompt like, what is your name? Inside quotes. Python will display this prompt, wait for the user to type something and press enter. Whatever they type will be stored as text in the variable username. So, if they type Bob, username will contain Bob. You can then print hello, username, to greet them. 3.5 Type conversion casting. A very important detail about input is that it always returns a string, even if the user types numbers. If you need to perform mathematical operations on this input, you'll need to convert it to a numeric type integer or float first. This process is called type conversion or casting. You can convert data types using built-in functions like int, float, and str. For print, hash ageIster equals input, enter your age. Hash user types 30. Hash agent equals int ageIster. Hash convert 30 to the number 30. Birth year equals 2023, agent. Print, you were born in birth year. Price ester, 19.99. Price of float equals float, price ester. Hash print, price of float 2 hash output, 39.98. Number equals 123. Numberster equals str, number. Hash print type numberster, hash output, class str. Verbal explanation for audio. If you ask the user for their age using input, enter your age, and they type 30, the variable ageIster will contain the text 30. To do math with it, like subtracting it from the current year, you need to convert it to a number. You do this by calling the int function and passing ageIster to it. Agent equals int ageIster. Now, agent contains the number 30, and you can calculate their birth year. Similarly, float converts text like 19.99 into a decimal number, and str converts numbers or other types into text form. 3.6 Comments. Explaining your code. As programs grow, they can become complex. Comments are notes within your code that the Python interpreter completely ignores. They don't affect how the program runs, but they are incredibly important for humans reading the code. They help you or anyone else understand what your code is doing, why it's doing it, and how it works. There are two main ways to write comments in Python: single-line comments. Start with a hash symbol. Anything after the hash on that line is a comment. Multi-line comments, docstrings. While technically multi-line strings, these are often used as comments for larger blocks of code or to document functions and classes. We'll cover functions and classes later. They are enclosed in triple quotes, or for print, hash hash. This is a single-line comment, hash. Hash userage equals 25, hash. This comment explains what userage stores. This is a multi-line comment. It can span several lines, useful for explaining complex logic. Verbal explanation for audio. A single-line comment begins with a hash symbol, also known as a pound sign. Everything after that hash symbol on the same line is ignored by Python. For example, if you set userage to 25, you could add hash. This comment explains what userage stores on the same line. For comments that span multiple lines, you can use 3 single quotes or 3 double quotes at the beginning and end of your comment block. This is often used for longer explanations in the code. Good comments are concise, relevant, and explain the why behind the code, not just the what. Try it yourself. Create variables. Create a variable called city and assign it the string value of your hometown. Create a variable called population and assign it an integer value, e.g., 100,000. Create a variable called temp Celsius and assign it a float value, e.g., 25.5. Using print, display the value and type of each variable. You can use type variable name inside print to see its type. Practice operators. Set 2 variables, num1 equals 7 and num2 equals 2. Perform and print the result of num1 divided by num2 using num1 floor divided by num2 using num1 modulo num2 using percent num1 raised to the power of num2 using try num1 equals num2 and num1 equals num2. What are the results? Interactive greeting. Write a program that uses input to ask the user for their favorite color. Store their answer in a variable. Then, using an f-string, print a creative message that incorporates their favorite color, such as your favorite color is simply vibrant. Simple age calculator, asterisk. Ask the user for their birth year using input. Convert the input to an integer. Calculate their approximate age, current year, birth year. Print their age using an f-string message. Remember to use int to convert the current year if you hardcode it. These exercises will help solidify your understanding of variables, data types, operators, and basic input-output. In the next chapter, we'll build on these foundations by exploring Python's powerful data structures. Chapter 4, Data Structures, Organizing Your Information. In the previous chapter, we covered the fundamental building blocks of Python: variables, basic data types like numbers and strings, and operators for manipulating them. We learned how to store individual pieces of information. But what if you have many related pieces of information that you want to store and manage together? Imagine you have a list of names, a collection of temperatures, or a record of a person's details. Storing each item in a separate variable would quickly become unwieldy and inefficient. This is where data structures come in. Data structures are ways of organizing and storing data in a computer so that it can be accessed and modified efficiently. Python provides several powerful, built-in data structures that are incredibly versatile and form the backbone of almost every Python program. In this chapter, we'll explore Python's 4 main built-in collection types: lists, tuples, sets, and dictionaries. We'll learn their characteristics, how to use them, and when to choose one over the others. 4.1 Lists, ordered, changeable collections. The list is arguably the most versatile and widely used data structure in Python. It's an ordered sequence of items where each item can be of any data type: strings, numbers, even other lists. Lists are also mutable, meaning you can change their contents after they've been created. Think of a list as a shopping list. You can add items, remove items, change an item, or even check the item at a specific position. 4.1.1 Creating lists. Lists are created by placing items inside square brackets, separated by commas. For print, hash an empty list. Empty list equals hash print empty list hash output hash a list of strings. Fruits equals apple, banana, cherry. Hash print fruits hash output apples, banana, cherry. Hash a list of numbers. Numbers equals 1, 2, 3, 4, 5. Hash print numbers hash output 1, 2, 3, 4, 5. Hash a list with mixed data types. Mixed list John 30 true 1.75. Hash print mixed list hash output John 30 true 1.75. Verbal explanation for audio. To create a list, you use square brackets. An empty list is just empty list equals open and close square brackets. For a list of strings like fruits, you'd have fruits equals open square bracket, then apple in quotes, comma, banana in quotes, comma, cherry in quotes, and close square bracket. You can also have lists of numbers, or even lists with mixed types, like names, ages, and Boolean values. 4.1.2 Accessing list items, indexing. List items are ordered, meaning they have a defined position, or index. In Python, indexing starts at 0 for the first item. To access an item, use square brackets with the index number. Negative indexing accesses items from the end of the list. -1 is the last item, -2 is the second to last, and so on. For print, fruits equals apple, banana, cherry, orange. Hash accessing items by positive index. Hash print fruits 0, hash output. Apple first item. Hash print fruits 2, hash output. Cherry third item. Hash accessing items by negative index. Hash print fruits -1, hash output. Orange last item. Hash print fruits -2, hash output. Cherry second to last. Verbal explanation for audio. Imagine the fruits list. Apple, banana, cherry, orange. To get the first item, you'd use fruits then open square bracket 0 close square bracket. This gives you apple. To get the third item, you'd use fruits then open square bracket 2 close square bracket. This gives you cherry. You can also count from the end using negative numbers. Fruits then open square bracket -1 close square bracket gives you orange, the very last item. 4.1.3 Slicing lists. You can access a range of items from a list using the slicing syntax. List start, end. The slice includes items from start up to, but not including end. If start is omitted, it defaults to 0. If end is omitted, it defaults to the end of the list. For print, numbers equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Hash print numbers 2, 5, hash output, 2, 3, 4, items at index 2, 3, 4. Hash print numbers 4, hash output, 0, 1, 2, 3, from beginning up to index 3. Hash print number 7, hash output, 7, 8, 9, from index 7 to the end. Hash print numbers, hash output, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A copy of the whole list. Verbal explanation for audio. If you have a list numbers from 0 to 9, numbers open square bracket 2:5 close square bracket gives you items at index 2, 3, and 4, which are 2, 3, 4. If you leave out the first number, like numbers open square bracket 4 close square bracket, it starts from the beginning, giving you 0, 1, 2, 3. If you leave out the second number, like numbers open square bracket 7 close square bracket, it goes from index 7 to the end. 4.1.4 Modifying lists. Since lists are mutable, you can change individual items, add new items, or remove existing ones. Changing an item, assign a new value to an item at a specific index. Hash for print, hash fruits equals apple, banana, cherry. Hash fruits 1 equals grape hash change banana to grape. Hash print fruits hash output, apple, grape, cherry. Verbal explanation for audio. If fruits is apple, banana, cherry, and you say fruits open square bracket 1 close square bracket equals grape, then the banana at index 1 is replaced by grape. Adding items, append item, adds an item to the end of the list. Insert index item, inserts an item at a specified index. Hash for print, hash fruits append, kiwi. Hash print fruits hash output, apple, grape, cherry, kiwi. Hash fruits dot insert 1, orange, hash insert orange at index 1. Hash print fruits hash output, apple, orange, grape, cherry, kiwi. Verbal explanation for audio. To add an item to the end, you use fruits append, kiwi. To add an item at a specific position, like the second position, you use fruits.insert 1, orange, removing items, remove item. Removes the first occurrence of a specified item. Pop index removes and returns the item at a specified index. If no index is given, it removes and returns the last item. Del list index deletes the item at a specific index. Clear removes all items from the list. Hash for print, hash fruits remove, grape. Hash print fruits hash output, apple, orange, cherry, kiwi. Hash last fruit equals fruits pop, hash removes kiwi. Hash print last fruit hash output, kiwi. Hash print fruits hash output, apple, orange, cherry. Hash del fruit 0 hash deletes apple. Hash print fruits hash output, orange, cherry. Verbal explanation for audio. To remove an item by its value, you use remove, for example, fruits remove, grape. To remove the last item, you use fruits pop. You can also use pop with an index, like fruits pop 0, to remove the first item. Another way to remove by index is using the del keyword, like del fruits open square bracket 0 close square bracket. 4.1.5 List methods and other operations. Lists have many useful built-in methods, functions that belong to the list object. Len listName returns the number of items in a list. List sort sorts the list in ascending order in place. Sorted list returns a new sorted list, doesn't modify original. List reverse reverses the order of items in place. List.count item returns the number of times an item appears. List.index item returns the index of the first occurrence of an item. You can also use the in operator to check if an item exists in a list. For print, mylist equals 10, 5, 20, 15, 5. Hash print len mylist, hash output, 5. Mylist sort, hash print mylist hash output, 5, 5, 10, 15, 20. Hash print 5 in mylist, hash output, true. Hash print 25 in mylist, hash output, false. Verbal explanation for audio. Len then parentheses with your list name will give you the number of items. Your list.sort will sort the list. And you can check if an item is in a list using the word in. For example, 5 in my list would be true. 4.2 Tuples, ordered unchangeable collections. Tuples are similar to lists in that they are ordered sequences of items. However, their defining characteristic is that they are immutable. This means once a tuple is created, you cannot change, add, or remove its items. Think of a tuple as a record that should not be altered, like coordinates on a map or the days of the week. 4.2.1 Creating tuples. Tuples are created by placing items inside parentheses, separated by commas. Parentheses are optional for clarity, but good practice. For print, hash hash an empty tuple. Empty tuple equals hash hash a tuple of numbers. Coordinates equals 10.0, 20.5. Hash print coordinates hash output 10.0, 20.5. Hash hash a tuple with mixed types. User info equals Bob42, developer. Hash print user info hash output Bob42, developer. Hash hash note. A single item tuple needs a trailing comma. Hash singletem tuple equals 5. Hash without the comma, it's just an integer in parentheses. Hash print type singletem tuple, hash output. Class tuple, nota tuple equals 5. Hash print type nota tuple, hash output, class int. Verbal explanation for audio. Tuples are created using parentheses. For example, coordinates equals open parenthesis 10.0, 20.5 close parenthesis. A common mistake is trying to create a tuple with only one item. If you just have 5, Python treats it as a number 5 inside parentheses. To make it a single item tuple, you must add a comma after the item. 5. 4.2.2 Accessing tuple items. Accessing tuple items works exactly like lists, using indexing and slicing. For print, userinfo equals Bob42, developer. Hash print userinfo 0, hash output, Bob. Hash print userinfo 1, hash output, 42, developer. Verbal explanation for audio. Just like lists, you access tuple items using square brackets with the index number, like userinfo open square bracket 0 close square bracket. Slicing works the same way too. 4.2.3 Immutability of tuples. You cannot change, add, or remove items in a tuple after it's created. Attempting to do so will result in a type error. For print, MyTuple equals 1, 2, 3. Hash hash MyTuple 0 equals 5 hash. This would cause a type error. Tuple object does not support item assignment. Verbal explanation for audio. If you try to change an item in a tuple, like saying MyTuple open square bracket 0 close square bracket equals 5, Python will give you a type error. This is because tuples are unchangeable. 4.2.4 When to use tuples. Tuples are often used for fixed collections of related items, where the order and number of items are important and shouldn't change, e.g., coordinates, RGB color values, database records. Function arguments and returns. Functions can easily return multiple values as a tuple. As dictionary keys, unlike lists, tuples can be used as keys in dictionaries because they are immutable. 4.3 Sets. Unordered, unique collections. A set is an unordered collection of unique items. This means two things. The items in a set do not have a defined order, so you cannot access them by index. A set cannot contain duplicate values. If you try to add a duplicate, it will simply be ignored. Think of a set as a mathematical set, a collection of distinct elements. 4.3.1 Creating sets. Sets are created using curly braces or the set constructor. For print, hash hash creating a set of numbers. Unique numbers equals 1, 2, 3, 4, 5. Hash print unique numbers hash output 1, 2, 3, 4, 5. Order might vary. Hash hash sets automatically remove duplicates. Numbers with duplicates equals 1, 2, 2, 3, 4, 4, 5. Hash print numbers with duplicates hash output 1, 2, 3, 4, 5. Duplicates removed. Hash hash creating a set from a list, useful for finding unique items. MyList equals 1, 2, 2, 3, 3, 3. Unique from list equals set MyList. Hash print unique from list hash output 1, 2, 3. Hash hash creating an empty set important creates an empty dictionary. Empty set equals set. Hash print empty set hash output set. Verbal explanation for audio. You create sets using curly braces, like unique numbers equals open curly brace 1, 2, 3, 4, 5 close curly brace. If you put duplicates in, like 1, 2, 2, 3, 4, 4, 5, the set will automatically remove the duplicates, leaving only the unique items. You can convert a list to a set to easily find unique items. To create an empty set, you must use the set function, because just empty curly braces creates an empty dictionary, which we'll learn about next. 4.3.2 Set operations. Sets are powerful for performing common mathematical set operations. Add item adds an item to the set. Remove item removes an item, raises an error if item not found. Discard item removes an item, no error if item not found. Union or returns a new set containing all unique items from both sets. Intersection or and returns a new set containing only items common to both sets. Difference or returns a new set with items in the first set but not in the second. Is-subset, is-superset, is-disjoint, for checking relationships between sets. For print, CETA equals 1, 2, 3, 4. Set equals 3, 4, 5, 6. Hash print SETA union set, hash output 1, 2, 3, 4, 5, 6. Hash print SETA dot intersection set, hash output 3, 4. Hash print SETA difference set, hash output 1, 2. Verbal explanation for audio. If CETA has 1, 2, 3, 4 and SET has 3, 4, 5, 6, their union, or you can use the vertical bar symbol, gives you all unique items from both 1, 2, 3, 4, 5, 6. Their intersection, or the ampersand symbol, gives you only the common items 3, 4. Their difference, or the minus symbol, gives you items in the first set that are not in the second 1, 2. 4.3.3 When to use sets. Sets are ideal when you need to store a collection of unique items. The order of items doesn't matter. You need to perform mathematical set operations, union, intersection, etc., efficiently. You need to quickly check for membership, item in my set. 4.4 Dictionaries, unordered key-value pairs. A dictionary, often called a map, or associative array in other languages, is an unordered collection of key-value pairs. Each item in a dictionary has a key and a corresponding value. Keys must be unique and immutable, like strings, numbers, or tuples, while values can be any data type and can be duplicated. Think of a dictionary like a physical dictionary or a phone book. You look up a word, the key, to find its definition, the value, or you look up a person's name, the key, to find their phone number, the value. 4.4.1 Creating dictionaries. Dictionaries are created using curly braces with key, value pairs separated by commas. For print, # an empty dictionary. Emptydict equals #print emptydict #output. # a dictionary representing a person's info. Person equals name, Alice, age, 30, city, New York. #print person #output, name, Alice, age, 30, city, New York. # keys can be numbers. Student scores equals 1,195, 1,288, 1,392. Verbal explanation for audio. Dictionaries use curly braces too, but they contain key value pairs. Each pair has a key, then a colon, then its value, and pairs are separated by commas. For example, a person dictionary could have a key name, in quotes, colon, value Alice, in quotes, comma, then a key age, in quotes, colon, value 30, and so on. 4.4.2 Accessing dictionary values. Values are accessed using their corresponding keys inside square brackets. For print, person equals name, Alice, age, 30, city, New York. #print person name, #output, Alice. #print person age, #output, 30. #print person country. This would cause a key error if country doesn't exist. ## using get method to avoid key error. #print person get city, #output, New York. #print person get country unknown, #output. Unknown provides default if key not found. Verbal explanation for audio. To get a value from a dictionary, you use the dictionary name, then square brackets, and inside the brackets, the key you want to look up. So person opens square bracket name, in quotes close square bracket would give you Alice. If you try to access a key that doesn't exist, you'll get an error. To avoid this, you can use the get method. If you say person get country and country isn't there, it returns none instead of an error. You can also provide a default value like person get country unknown, which will return unknown if the key is missing. 4.4.3 Modifying dictionaries. Dictionaries are mutable. You can add new key value pairs, change existing values, or remove pairs. Adding changing values. Assign a value to a new or existing key. For print. #person occupation equals engineer, #add new key value pair. #print person #output. Name, Alice, age, 30, city, New York, occupation, engineer. #person a equals 31 change existing value. #print person #output. Name, Alice, age, 31, city, New York, occupation, engineer. Verbal explanation for audio. To add a new key value pair, you just assign a value to a new key. Person open square bracket occupation, in quotes close square bracket equals engineer. To change an existing value, you do the same, but the key already exists. Removing items, del dict key, deletes the item with the specified key. Pop key removes the item with the specified key and returns its value. Clear removes all items. For print, #del person city. #print person #output. Name, Alice, age, 31, occupation, engineer. #removeage equals person pop, age. #print removeage #output. 31. #print person #output. Name, Alice, occupation, engineer. Verbal explanation for audio. You can use del plus the dictionary name and the key in square brackets to remove an item. Or you can use the pop method with the key to remove the item and also get the value back, like you might with a list. 4.4.4 Dictionary methods. Len dictname returns the number of key value pairs. Dict keys returns a view of all keys in the dictionary. Dict values returns a view of all values in the dictionary. Dict.items returns a view of all key value pairs as tuples. Key in dict. Check if a key exists in the dictionary returns Boolean. For print, person equals name, Alice, age, 30, city, New York. #print person keys. #output dict keys name, age, city. #print person values. #output. Dict values Alice, 30, New York. #print person dot items. #output dict items, name, Alice, age, 30, city, New York. #print name and person #output, true. #print country and person hash output. Vals, verbal explanation for audio. You can get all the keys using person keys, all the values using person values, or both as pairs using person.items. You can also use the in operator to check if a specific key exists in the dictionary. For example, name in person would be true. 4.5. Choosing the right data structure. With 4 powerful collection types, how do you decide which one to use? Here's a quick guide. Use a list when you need an ordered collection of items. You need to be able to change, add, or remove items after creation. You need to access items by their numerical index. You might have duplicate items. Examples: a list of tasks, a sequence of measurements, player scores in a game. Use a tuple when you need an ordered collection of items. You need to ensure the collection cannot be changed after creation, immutability. This adds data integrity. You need to use the collection as a dictionary key because they are immutable. Examples: coordinates x, y, a date, year, month, day, a fixed set of options. Use a set when you need a collection of unique items. The order of items does not matter. You need to perform mathematical set operations, union, intersection, etc. You need to check for membership quickly, e.g., is this item present in this large collection? Examples: a collection of unique tags, a list of registered users, finding common elements between 2 groups. Use a dictionary when you need to store data as key-value pairs. You need to retrieve values based on a descriptive key rather than a numerical index. The collection is mutable, so you can add, change, or remove pairs. Examples: user profiles, name, age, email, configuration settings, a mapping of product IDs to product names. Understanding these distinctions is crucial for writing efficient, readable, and well-structured Python programs. Try it yourself. Work with lists. Create a list called My Hobbies with at least 5 hobbies, e.g., reading, hiking, cooking. Print the length of the list. Print the first hobby and the last hobby. Add a new hobby to the end of the list. Change one of your existing hobbies to something else. Remove one hobby from the list. Print the final list. Explore tuples. Create a tuple called RGB color storing an RGB color code, e.g., 255, 0, 128. Print the second value of the tuple. Try to change the first value of the tuple, e.g., RGB color 0 equals 0. What happens? Note the error type. Explain why this error occurs in your own words. You can add a comment to your code. Experiment with sets. Create a list with some duplicate numbers, e.g., numbers equals 1, 5, 2, 5, 1, 8, 2, 9. Convert this list to a set called uniquenumbers. Print uniquenumbers. What do you observe? Create another set, even numbers equals 2, 4, 6, 8, 10. Find the intersection of uniquenumbers and even numbers. Print the result. Build a dictionary. Create a dictionary called book with the following key-value pairs. Title: The Hitchhiker's Guide to the Galaxy. Author: Douglas Adams. Year: 1979. Genre: science fiction. Print the author of the book. Add a new key-value pair. Pages: 193. Change the year to 1980. Remove the genre from the dictionary. Print the entire book dictionary. Check if publisher is a key in the book dictionary using the in operator. These exercises will give you hands-on experience with Python's core data structures, helping you understand their unique properties and when to use them. Mastering these will be incredibly valuable as you move on to building more complex programs. Chapter 5. Control Flow, Making Decisions and Loops in Your Programs. In the previous chapter, we learned how to organize data using Python's fundamental data structures like lists, tuples, sets, and dictionaries. You've learned how to store and access information. But a program that just stores data and prints things in a static order isn't very useful in the real world. Real-world applications need to be dynamic. They need to make decisions, respond to different conditions, and repeat actions efficiently. This dynamic behavior is achieved through control flow. Control flow statements dictate the order in which individual instructions or statements are executed in a program. They allow your program to be intelligent and adaptable, executing different code paths based on circumstances or repeating a set of instructions multiple times. In this chapter, we'll cover the core control flow mechanisms in Python. Conditional statements, if, elif, else, for making decisions and executing code blocks only when certain conditions are met. Loops, for, while, for repeating blocks of code multiple times. 5.1 Conditional statements. Making decisions, if, elif, else. Imagine you're writing a program for a vending machine. If a user inserts enough money and selects an available item, the machine dispenses the item. Otherwise, it might display an error or prompt for more money. This is a classic example of decision-making, where different actions are taken based on different conditions. In Python, decision-making is handled by if, elif, short for else if, and else statements. These statements rely on Boolean expressions, which evaluate to true or false, just like the comparison and logical operators we learned in Chapter 3. 5.1.1 The if statement. The if statement is the simplest form of a conditional. It executes a block of code only if a specified condition is true. Syntax, for print, if condition, # code to execute if condition is true. Verbal explanation for audio. The syntax is the word if followed by your condition, then a colon. On the next line, indented, usually by 4 spaces, is the code that will run if the condition is true. Example, for print, age equals 20. If age equals 18, print, you are an adult. Verbal explanation for audio. If age is 20 and the condition is age greater than or equal to 18, which is true, then the indented line print, you are an adult, will execute. 5.1.2 The else statement. Often, you want to perform one action if a condition is true and a different action if the condition is false. The else statement allows you to define this alternative block of code. Syntax. For print, if condition, # code if condition is true. Else, # code if condition is false. Verbal explanation for audio. The else statement follows an if block. It starts with the word else, then a colon. The indented code below else will run only if the if condition was false. Example, for print, temperature equals 25. If temperature 30, print, it's hot outside. Else, print, the weather is pleasant. Verbal explanation for audio. If temperature is 25, the condition temperature greater than 30 is false, so the print statement under else will execute, showing the weather is pleasant. 5.1.3 The elif statement. What if you have multiple possible conditions where only one outcome should occur? This is where elif, short for else if, comes in. It allows you to check additional conditions if the preceding if or elif conditions were false. Python evaluates if /elif /else statements sequentially, and as soon as one condition is met true, its corresponding code block is executed, and the rest of the chain is skipped. Syntax, for print, if condition 1, # code if condition 1 is true. Elif condition 2, # code if condition 2 is true and condition 1 was false. Else, # code if all above conditions were false. Verbal explanation for audio. You start with an if condition. If that's false, then elif, which means else if, allows you to check another condition, like condition 2. You can have multiple elif blocks. If all the if and elif conditions are false, then the else block, if present, will execute. Example, for print, score equals 85. If score equals 90, print, grade. #elif score equals 80. This is checked only if score 90. Print, grade B. #elif score equals 70. This is checked only if score 80. Print, grade C. Else print, grade F. Verbal explanation for audio. If score is 85, the first if score greater than or equal to 90 is false, so it moves to the elif score greater than or equal to 80. This is true, so grade B is printed, and the rest of the conditions are ignored. 5.1.4 Combining conditions with logical operators. You can build more complex conditions using the logical operators and, or, and not that we discussed in Chapter 3. For print, age equals 16. Parental consent equals true. If age equals 18 or parental consent, print, access granted. Else print, access denied. Username equals admin. Password 123. If username equals admin and password equals Securipass. Print, admin login successful. Elif username equals admin and password. Securipass. Print, invalid password for admin. Else print, invalid username. Verbal explanation for audio. For age 16 and has parental consent being true, the condition age greater than or equal to 18 or has parental consent is evaluated. Even though the first part, age greater than or equal to 18, is false, the second part, has parental consent, is true. Because of the or operator, the entire condition becomes true and access granted. Is printed. For a login example, if username is admin and password is password123. The first if condition username is admin and password is securipass is false because the password doesn't match. It moves to the if username is admin and password is not securipass. This is true, so invalid password for admin is printed. 5.2 loops, repeating actions for while. Loops are essential for automating repetitive tasks. Instead of writing the same code multiple times, you can tell your program to repeat a block of code a certain number of times or until a condition is met. 5.2.1 The for loop. Iterating over sequences. The for loop is used for iterating over a sequence, like a list, tuple, string, or range or other iterable objects. It executes a block of code once for each item in the sequence. Syntax. For print, for item in sequence, ## code to execute for each item. Verbal explanation for audio. The syntax is the word for, then a variable name, item in this case, that will temporarily hold each element, then the word in, then the sequence you want to loop through, and finally a colon. The indented code below will run for each item in the sequence. Example, iterating over a list. For print, fruits equals apple, banana, cherry. For fruit and fruits, print I like fruit. Verbal explanation for audio. If fruits is apple, banana, cherry, the for loop will first assign apple to the variable fruit, then run the print statement. Then it assigns banana to fruit and runs print again. Finally, it assigns cherry to fruit and runs print one last time. The output would be, I like apple, I like banana, I like cherry, on separate lines. The range function, often you need to loop a specific number of times. The range function generates a sequence of numbers, which is very useful with for loops. Range stop generates numbers from 0 up to, but not including, stop. Range start stop generates numbers from start up to, but not including, stop. Range start stop step generates numbers from start up to stop, incrementing by step. For print, # for I in range 3. #I will be 0, 1, 2. Print f count, I. # for year in range, 2020, 2023. #year will be 2020, 2021, 2022. Print f processing data for year. # for j in range, 0, 10, 2. #j will be 0, 2, 4, 6, 8. Print j. Verbal explanation for audio. Range 3 creates a sequence of numbers 0, 1, 2. So, a for loop using range 3 will run 3 times. Range 2020, 2023 creates 2020, 2021, 2022. Range 0, 10, 2 starts at 0, goes up to, but not including, 10 in steps of 2. So it produces 0, 2, 4, 6, 8, 5.2.2 the while loop, repeating until a condition is met. The while loop repeatedly executes a block of code, as long as a specified condition remains true. It's great when you don't know in advance how many times you need to loop. Syntax. For print, while condition, ## code to execute as long as condition is true. Verbal explanation for audio. The syntax is the word while followed by your condition, then a colon. The indented code below will keep running as long as the condition is true. Example, for print, count equals 0. While count 5, print f count is count, #count plus equals 1 # important. This changes the condition to eventually become false. Print loop finished. Verbal explanation for audio. Count starts at 0. The while loop checks, is count less than 5? Yes, 0 is less than 5, so it prints count is 0. Then count is increased by 1, count plus equals 1, making it 1. The loop checks again, is count now 1 less than 5? Yes. Prints count is 1. Increases count to 2. This continues until count becomes 5. At that point, count less than 5 is false, so the loop stops and loop finished is printed. Caution, infinite loops, be very careful with while loops. If the condition never becomes false, your program will run forever in an infinite loop. consuming CPU resources. Always ensure there's a mechanism inside the loop to eventually change the condition to false. 5.2.3 Controlling loops. Break and continue. Sometimes you need more fine-grained control over loops. Break immediately terminates the loop, both for and while, and transfers control to the statement immediately following the loop. Continue skips the rest of the current iteration of the loop and moves to the next iteration. For print, # example with break. For number in range 110, if number equals 5. #break #exit loop when number is 5. Print f number break, number. Print # example with continue. For number in range 110, if number %2 == 0. If number is even. Continue skip to next iteration. Print f number continue, number. Only odd numbers will be printed. Verbal explanation for audio. In the break example, the loop starts from 1. When number becomes 5, the if condition is met and break is executed. This immediately stops the entire for loop, so 5, 6, 7, 8, 9 are never printed. In the continue example, the loop iterates from 1 to 9. When number is 2, an even number modulo 2 = 0 is true, and continue is executed. This immediately skips the print statement for this iteration and moves to the next number, 3. So only odd numbers, 1, 3, 5, 7, 9, will be printed. 5.2.4 Looping with enumerate and zip. Advanced but useful. Enumerate. When iterating over a list or other sequence, you often need both the item and its index. Enumerate provides this conveniently. For print, fruits = apple, banana, cherry. For index, fruit and enumerate fruits. Print f item index, fruit. Verbal explanation for audio. To get both the index and the item from a list, you can use enumerate. You'd write for index, fruit and enumerate fruits. This way, index will represent the position 0, 1, 2, etc., and fruit will hold the actual item, apple, banana, etc. for each turn of the loop. Zip. When you have multiple lists of the same length and want to iterate over them simultaneously, zip is incredibly useful. For print, names = Alice, Bob. Scores = 90, 85. For name, score and zip, names, scores. Print f name scored score. Verbal explanation for audio. If you have two lists, names and scores, and you want to pair them up, you use zip. You can say for name, score and zip, names, scores. In the first loop, name will be Alice and score will be 90. In the second, name will be Bob and score will be 85. Try it yourself. Grade calculator, conditional practice. Ask the user to enter a numeric score using input. Remember to convert the input to an integer. Using if, elif, and else statements, print the corresponding letter grade, 90 to 100, A, 80 to 89, B, 70 to 79, C, 60 to 69, D, below 60, F. Test your program with different scores, e.g. 95, 82, 70, 55. Count down while loop practice. Write a program that uses a while loop to count down from 5 to 1, printing each number. After the loop, print liftoff. Even or odd for loop and modulo, create a list of numbers. My numbers = 12, 7, 45, 8, 23, 10. Use a for loop to iterate through my numbers. Inside the loop, use an if-else statement and the modulo operator % to determine if each number is even or odd, and print the result, e.g., 12 is even, 7 is odd. Interactive shopping list combining concepts. Create an empty list called shopping list. Use a while loop that continues until the user types done. Inside the loop, prompt the user to enter an item or done to finish. If the user types done, break the loop. Otherwise, add the entered item to the shopping list. After the loop finishes, use a for loop to print all items in the shopping list, one per line, preceded by a number, e.g., 1. Milk, 2 eggs. You might find enumerate useful here. These exercises will give you hands-on experience in controlling the flow of your programs, allowing them to make decisions and perform repetitive tasks. These concepts are foundational to all programming, and mastering them is a crucial step in your software development journey. Chapter 6: Functions and Modularity. Building reusable code. So far, we've learned about variables, data types, and control flow using conditional statements and loops. With these tools, you can write programs that can make decisions and perform repetitive tasks. However, as programs grow larger, you'll find yourself writing the same or very similar blocks of code multiple times. This leads to code that is harder to read, maintain, and debug. Imagine writing a recipe. Instead of detailing how to chop an onion, every time it's needed throughout the recipe, you define a process for it once, maybe under preparation tips, and then simply say chop onion whenever that step is required. In programming, this concept is called modularity, and the primary tool for achieving it is the function. A function is a block of organized, reusable code that performs a specific, single, well-defined task. Using functions makes your code reusable, write once, use many times, easier to read, break down complex problems into smaller, manageable chunks, easier to maintain. If a task changes, you only need to modify the function's code in one place. Easier to debug, isolate problems to specific functions. In this chapter, we'll learn how to define and use functions in Python, understand parameters and arguments, delve into return values, and explore the concept of scope. 6.1 Defining Functions Def Keyword. You've already used many built-in Python functions like print, input, len, int, and str. Now, you'll learn how to create your own custom functions. Functions are defined using the def keyword, followed by the function name, parentheses, and a colon. The code block that makes up the function must be indented. Syntax: for print, def function name, # code block, indented. Print: this code runs inside the function. Verbal explanation for audio. To define a function, you start with the keyword def, then give your function a meaningful function name. After the name, there are open and close parentheses, then a colon. The code that belongs to this function is written on the next lines and must be indented, usually by 4 spaces. Example: for print, def greet. Print hello user. Print welcome to our program. # calling the function. Greet. Print. Greet. Verbal explanation for audio. Here, we define a function called greet. Inside, it prints hello user and welcome to our program. To make this code run, you call the function by simply typing its name followed by parentheses. Greet. You can call it multiple times, and each time, it will execute the code defined within the greet function. This avoids repeating the print statements. 6.2 Function parameters and arguments. Functions become even more powerful when they can operate on specific pieces of data that you pass to them. These pieces of data are called arguments, and the variables that receive these arguments inside the function are called parameters. Think of a function as a machine. Parameters are the input slots on the machine, and arguments are the specific items you put into those slots when you run the machine. 6.2.1 Positional arguments. The most common way to pass arguments is by position. The first argument you pass corresponds to the first parameter, the second to the second, and so on. For print, #def personalize greet name. #name is a parameter. Printf hello name. Print welcome to our personalized program. ## calling the function with arguments. #personalize greet Alice. #Alice is an argument. #personalize greet Bob. #Bob is an argument. Verbal explanation for audio. We define personalize greet with a name parameter inside the parentheses. Inside the function, we use an f-string to print a greeting including that name. When we call personalize greet Alice, the string Alice is passed as an argument and assigned to the name parameter for that particular call. When we call personalize greet Bob, Bob is passed. 6.2.2 Multiple parameters. You can define functions with any number of parameters, separated by commas. For print, def add numbers, num1, num2. Sum result equals num1 plus num2. Printf the sum is sum result. #add numbers 10 5 #output. The sum is 15. #add numbers 7 3 #output. The sum is 10. Verbal explanation for audio. The add numbers function takes 2 parameters, num1 and num2. It adds them together and prints the sum. When you call add numbers 10 5, num1 becomes 10 and num2 becomes 5. 6.2.3 Default arguments. Sometimes, a parameter might have a common default value. You can specify a default value for a parameter in the function definition. If the caller doesn't provide an argument for that parameter, the default value is used. For print, def make pizza, size equals medium, topping equals cheese, print f making a size pizza with topping, hash make pizza, hash output, making a medium pizza with cheese, hash make pizza, large, hash output, making a large pizza with cheese, hash make pizza, small, pepperoni, hash output, making a small pizza with pepperoni. Verbal explanation for audio. The makepizza function takes size and topping parameters. We give size a default of medium and topping a default of cheese. If you call makepizza with no arguments, it uses the defaults. If you call makepizza large, it uses large for size but keeps cheese for topping. If you provide both like makepizza, small, pepperoni, it overrides both defaults. 6.2.4 Keyword arguments. You can also pass arguments using the parameter names, which are called keyword arguments. This allows you to pass arguments in any order, and it often makes your code more readable, especially for functions with many parameters. For print def describeperson name age city, print f name is age, years old and lives in city. Describeperson name equals John, age equals 45, city equals London. Hash describeperson city equals Paris, name equals Jane, age equals 28. Hash order doesn't matter with keyword arguments. Verbal explanation for audio. The describeperson function takes name, age, and city. When calling it, you can explicitly say name equals John, age equals 45, city equals London. The advantage is that the order doesn't matter, as shown in the second call where city comes first. This can make your code easier to understand. Note, once you use a keyword argument in a function call, all subsequent arguments must also be keyword arguments. Describeperson, Peter, age equals 30, city equals Berlin, is fine, but describeperson, name equals Kate, 30, New York, would be an error. 6.3 Return values. Getting results from functions. Many functions don't just perform an action, they also compute a value that you want to use later in your program. The return statement is used to send a value back from a function to the place where it was called. If a function doesn't explicitly return a value, it implicitly returns none. For print, def multiply a b, result equals a b. Hash return result hash, send the result back. Hash hash storing the returned value in a variable. Product equals multiply 4, 5. Hash print f the product is. Product hash output, the product is 20. Hash hash using the returned value directly. Hash print f double the product is. Multiply 372, hash output, double the product is 42. Def say hello, print hello. Hash hash no return statement, so implicitly returns none. Nothing equals say hello. Hash print nothing hash output hello, then none. Verbal explanation for audio. The multiply function takes a and b, calculates their product, and then uses return result to send that product back. When you call product equals multiply, 4, 5, the number 20 is returned by multiply and stored in the product variable. You can also use the returned value directly within an expression, like multiply 3, 7, 2. If a function doesn't have a return statement, like say hello, which just prints hello, it implicitly returns none. So if you capture its result in a variable like nothing equals say hello, nothing will contain the none value. 6.4 Scope. Local versus global variables. Scope refers to the region where a variable is accessible within your code. Understanding scope is crucial to avoid unexpected behavior in your programs. 6.4.1 Local scope. Variables defined inside a function are said to be in that function's local scope. They can only be accessed from within that function. They cease to exist once the function finishes executing. For print, def my function, hash localvar equals 10 hash localvar is in local scope. Print localvar, hash my function, hash output, 10, hash hash print, localvar, hash. This would cause a name error, as localvar is not defined in global scope. Verbal explanation for audio. In my function, localvar equals 10 is created. You can print it inside the function. But if you try to print localvar outside of my function, Python will say it's not defined because it only exists within the function's local scope. 6.4.2 Global scope. Variables defined outside any function are said to be in the global scope. They can be accessed from anywhere in the program, including inside functions. For print, hash globalvar equals 20 hash globalvar is in global scope. Def another function, hash print globalvar, hash can access globalvar. Hash another function, hash output, 20. Hash print globalvar hash output, 20. Verbal explanation for audio. If globalvar equals 20 is defined outside any function, it's accessible everywhere. Another function can print it, and you can print it directly from the main part of your script. 6.4.3 Modifying global variables. Caution. While you can read global variables from within a function, directly modifying them inside a function is generally discouraged because it can lead to code that is hard to track and debug. If you absolutely must modify a global variable from inside a function, you need to use the global keyword. For print, hash counter equals 0 hash global variable. Def increment counter, hash global counter, hash declare intent to modify global counter. Counter plus equals 1. Hash print f before call, counter, hash output before call, 0. Increment counter, hash print f after call, counter, hash output. After call, 1. Verbal explanation for audio, counter is initially 0. Inside increment counter, we use global counter. This tells Python that when we say counter plus equals 1, we mean to modify the global counter variable, not create a new local one. Without global counter, if you just said counter plus equals 1 inside the function, Python would assume you're trying to create a new local variable called counter, which would typically lead to an error because you're trying to increment it before it has a value locally. It's generally better to pass variables as arguments and return new values, rather than modifying global variables directly inside functions. 6.5 Docstrings. Documenting functions. Good functions should not only perform a task, but also explain themselves. Python has a feature called docstrings, documentation strings, for this purpose. A docstring is a multi-line string, enclosed in triple quotes, that immediately follows the def line of a function. Docstrings explain what the function does, its parameters, what it returns, and any potential issues. They are crucial for code readability and can be accessed programmatically. For print, def calculator rectangularia, length, width, calculates the area of a rectangle. Args, length float, the length of the rectangle, width float, the width of the rectangle, returns, float, the calculated area. Area equals length width. Return area. Hash accessing the docstring. Print, calculator rectangularia doc. Verbal explanation for audio. After the def line, you place a multi-line string enclosed in triple quotes. This is the docstring. It describes what the function does, what arguments it expects and their types, and what it returns. Docstrings are incredibly important. You'll thank yourself and your colleagues will thank you when you write clear docstrings, especially for functions that perform complex tasks or will be reused by others. Try it yourself. Simple calculator functions. Define a function add, a, b, that returns the sum of a and b. Define a function subtract, a, b, that returns the difference of a and b. Define a function multiply, a, b, that returns the product of a and b. Define a function divide, a, b, that returns the result of a divided by b. Handle the case where b is 0, e.g., print an error and return none. Call each function with some numbers and print the results. Personalized greeting function with default. Define a function greeduser, name equals guest, that takes a name as a parameter, with guest as its default value if no name is provided. The function should print a personalized greeting message using the provided name. Call the function once without an argument and once with your name. Factorial calculator. Write a function called factorial, n, that calculates the factorial of a given non-negative integer and the factorial of n, written n. Is the product of all positive integers less than or equal to n, e.g. 5, equals 54321 equals 120. Hint, use a for loop and range. Starting from 1 up to n, the function should return the calculated factorial. Add a proper docstring to your factorial function. Call the function with a few different numbers, e.g. factorial 0, factorial 5. Refactor previous programs. Go back to your solution for the grade calculator from Chapter 5. Refactor it into a function getGrade, score, that takes a score as an argument and returns the letter grade A, B, C, D, or F. Now, in your main program, you can call getGrade and print the result. This makes your main code much cleaner. Mastering functions is a significant leap in your programming journey. They allow you to write more organized, efficient, and maintainable code, preparing you for more complex software development tasks. Chapter 7, Object-Oriented Programming (OOP) in Python, Thinking in Objects. So far, we've focused on what's called procedural programming, writing code as a sequence of instructions, where functions operate on data. This approach is perfectly fine for many tasks, especially smaller scripts. However, as programs grow larger and more complex, managing data and the functions that manipulate that data can become challenging. Imagine building a video game or a complex e-commerce website. You'd have many things involved: players, enemies, items, orders, customers, products. Each thing has its own characteristics, like player health, item price, and behaviors, like player attacking, item being purchased. Trying to manage these characteristics and behaviors separately can lead to messy, hard-to-maintain code. This is where object-oriented programming, OOP, comes in. OOP is a programming paradigm that organizes software design around objects, rather than functions and logic. An object can be thought of as a self-contained unit that bundles data, its characteristics, and the code that operates on that data, its behaviors. OOP allows us to model real-world entities, like a car, a bank account, or a person, as objects in our code, making programs more intuitive, modular, and easier to scale. In this chapter, we'll introduce the core concepts of OOP in Python: classes and objects, the blueprints and the instances; attributes, the data characteristics of an object; methods, the functions, behaviors of an object; encapsulation, bundling data and methods; inheritance, creating new classes based on existing ones; polymorphism, conceptual, objects of different classes responding to the same message. 7.1 Understanding classes and objects. The two fundamental concepts in OOP are classes and objects. Class. A class is like a blueprint or a template for creating objects. It defines the common characteristics, attributes, and behaviors methods that all objects of that type will have. It doesn't represent a specific instance, but rather the general idea. Analogy, the blueprint for a house. It defines how many rooms it has, where the windows are, etc., but it's not a house you can live in. Object or instance. An object is a specific instance of a class. It's a concrete realization of the blueprint. When you create an object from a class, you are instantiating the class. Each object will have its own unique set of values for the attributes defined by its class. Analogy, an actual house built from the blueprint. You can live in this specific house. You can have many houses built from the same blueprint, but each is a distinct house. Syntax for defining a class. Classes are defined using the class keyword. For print, class dog. # attributes, and methods will go here. #pass is a placeholder, means do nothing for now. Verbal explanation for audio. To define a class, you use the keyword class, followed by the class name. By convention, class names use capital case, then a colon and an indented block where you define the class's contents. For now, we'll use pass to make it a valid, empty class. Creating objects, instantiating a class. To create an object, or instance, from a class, you simply call the class name followed by parentheses. For print, #mydog equals dog, #mydog is now an object, an instance of the dog class. Yourdog equals dog. Verbal explanation for audio. After defining the dog class, creating an object is simple. Mydog equals dog, with parentheses. Mydog is now an object, basically a specific dog instance, created from the dog blueprint. You can create as many dog objects as you like. 7.2 Attributes, the data of an object. Attributes are variables that belong to an object. They store the data or characteristics of that specific object. When you define a class, you define what attributes its objects will generally have. The init method, constructor. The init method, note the double underscores before and after, is a special method in Python classes. It's called automatically whenever a new object is created from the class. It's often referred to as the constructor because it's where you initialize the object's attributes. Self, the first parameter of init and all instance methods, is always self. Self is a reference to the instance of the class that has just been created. It allows you to access variables that belong to that specific instance. You don't pass self explicitly when calling the constructor. Python handles it automatically. For print, class dog, ## the constructor method. Def init self name breed. #self.name equals name # instance attribute. #self.breed equals breed # instance attribute. ## creating objects with initial attributes. My dog equals dog, Buddy, golden retriever. Your dog, Lucy, Labrador. ## accessing attributes. #print mydog.name #output. Buddy. #print yourdog.breed #output. Labrador. Verbal explanation for audio. In our dog class, we define a special method init. It takes self, then name and breed as parameters. Inside init, we assign the name parameter to self.name. This creates an attribute called name for this object. We do the same for breed. When creating mydog, we pass Buddy and golden retriever as arguments. These go into the name and breed parameters, and then become mydog.name and mydog.breed. You access an object's attributes using dot notation, mydog.name or yourdog.breed. 7.3 Methods. The behaviors of an object. Methods are functions that belong to an object. They define the behaviors or actions that an object can perform, or actions that can be performed on the object. Just like init, all instance methods take self as their first parameter. For print, class dog, def init self name breed, self.name equals name. Self.breed equals breed. ## an instance method. Def bark self, print f self.name says woof. ## another instance method. Def describe self, print f self.name is a self.breed. My dog equals dog, Buddy, golden retriever. Your dog, Lucy, Labrador. ## calling methods. #mydog bark, #output. Buddy says woof, #yourdog.describe, #output. Lucy is a Labrador. Verbal explanation for audio. Inside our dog class, we now have a bark method. It takes self as its parameter. Inside, it uses self.name to print the dog's name followed by says woof. We also have a describe method that prints the dog's name and its breed. To call a method, you use dot notation on the object, just like with attributes, but you add parentheses. MyDogBark and YourDog.describe. 7.4 Encapsulation, bundling data and methods. Encapsulation is a core OOP principle, meaning that the data attributes and the code that operates on that data methods are bundled together within a single unit, the object. It also implies data hiding, where the internal state of an object is protected from direct external access and can only be modified through its methods. This prevents accidental corruption of an object's data. In Python, encapsulation is achieved more by convention than strict rules. There are no truly private attributes like in some other languages. However, a common convention is to prefix an attribute name with a single underscore, e.g., attribute name, to suggest it's intended for internal use, or with double underscores, e.g., attribute name, to make it harder to access from outside. Python mangles the name, making it less directly accessible. For print class bank account, def init self owner balance equals 0, self owner equals owner. #self balance equals balance #balance is name mangled. Def deposit self amount, if amount 0, self balance plus equals amount. Print f deposited amount, new balance, self balance. Else print deposit amount must be positive. Def withdraw self amount. If 0, amount lesser equals self balance. Self balance equals amount. Print f withdrew amount, new balance, self balance. Else print invalid withdrawal amount or insufficient funds. Def get balance self, return self balance. Account equals bank account, Alice. #account dot deposit, 100 #output. Deposited 100, new balance 100. #account withdraw 30 #output, withdrew 30, new balance 70. #print f current balance, account get balance, #output, current balance 70. #print account balance. This would typically result in an attribute error. Verbal explanation for audio. In this bank account example, balance, with two leading underscores, is meant to be handled internally. You don't typically access it directly. Instead, you interact with the account's balance through methods like deposit, withdraw, and get balance. This ensures that any changes to the balance go through the defined rules. Amount must be positive, amount must be less than or equal to current balance. This bundling of data balance and its operations deposit, withdraw within the bank account object is encapsulation. 7.5 Inheritance. Building on existing classes. Inheritance is a powerful OOP concept that allows you to define a new class based on an existing class. The parent class or base class or superclass is the existing class. The child class or derived class or subclass is the new class that inherits attributes and methods from the parent. This promotes code reuse and creates a hierarchical relationship between classes. A child class can extend or override the functionality of its parent. Analogy: a sports car class can inherit from a car class. A sports car is a car, so it automatically gets all the general car characteristics: wheels, engine, doors, and behaviors, drive, brake. But it can also add unique sports car attributes: spoiler, turbocharger, and behaviors: race mode. For print #class vehicle, #parent class, def init self brand model, self.brand equals brand, self model equals model, def display info self, print f brand, self.brand model, self model, #class car vehicle, #child class inheriting from vehicle, def init self brand model numdors #super, init brand model #call parents constructor, self numdors equals numdors, def honk self, print beep beep, #class bicycle vehicle, another child class inheriting from vehicle, def init self brand model type of bike super, init brand model, self type of bike equals type of bike, def ring bell self, print ring ring, my car equals car, Toyota Camry 4, my bicycle equals bicycle, giant, escape, hybrid, my car display info, inherited method, brand, Toyota model, Camry, my car honk, child specific method, beep beep, my bicycle display info, inherited method, brand, giant model, escape, my bicycle ring bell, child specific method, ring ring, print my car numdors, access child specific attribute. 4. Verbal explanation for audio. We have a vehicle class, our parent, with brand and model attributes and a display info method. Then we define a car class. Notice car, vehicle in its definition, meaning car inherits from vehicle. In car's init method, super. Init, brand, model, calls the vehicle parent's constructor to handle the brand and model attributes. Car also adds its own numdors attribute and a honk method. Similarly, bicycle inherits from vehicle and adds its own unique attributes, type of bike, and methods, ring bell. When you create a car object, it automatically has the display info method from vehicle, as well as its own honk method. This demonstrates how inherited methods and child-specific methods coexist. 7.6 Polymorphism. Different objects, same message conceptual. Polymorphism means many forms. In OOP, it refers to the ability of different objects to respond to the same method call in their own distinct ways. This often happens with inherited classes. Analogy: you can tell different types of vehicles to start. A car starts by turning a key or pushing a button, a bicycle starts by pedaling, a boat starts by cranking an engine. The command is the same, start, but the implementation varies depending on the type of vehicle. For print, class animal, def make sound self, pass placeholder method. Class dog animal, def make sound self, print woof. Class cat animal, def make sound self, print meow. Class cow animal, def make sound self, print moo. Animals dog, cat, cow. For animal in animals, animal make sound, same method call, different output, output, woof, meow, moo. Verbal explanation for audio. We have a base animal class with a make sound method as a placeholder. Then dog, cat, and cow classes inherit from animal, and each provides its own specific implementation of the make sound method. When you put instances of all these animals into a list and then loop through them, calling animal make sound, for each, the same method call produces a different sound output: woof, meow, moo. depending on the actual type of animal object. This is polymorphism, objects of different types responding to the same message in their unique ways. OOP is a powerful paradigm that can greatly improve the organization, reusability, and scalability of your code. While it might seem abstract at first, practicing with classes and objects will help solidify these concepts. Try it yourself. Create a book class, define a class called book. The init method should take title, author, and numpages as parameters. Initialize these as instance attributes. Add a method displayInfo, self, that prints the book's title, author, and number of pages in a readable format. Create two book objects and call their displayInfo methods. Model a rectangle, define a class rectangle. The init method should take width and height. Add a method calculateArea, self, that returns the area of the rectangle. Add a method calculatePerimeter, self, that returns the perimeter of the rectangle. Create a rectangle object and print its area and perimeter. Inheritance, student from person. Define a person class, parent class, with init taking name and age. Add a greet, self method that prints hello, my name is name. Define a student class, child class, that inherits from person. The student's init should take name, age, and studented. Make sure to call the person's init using super. Init, name, age. Add a new method study, self, to the student class that prints name, ID. Studented is studying. Create a student object. Call its inherited greet, method, and its specific study, method. These exercises will give you hands-on experience in defining classes, creating objects, and implementing basic OOP principles. These are fundamental skills for building larger, more complex, and well-structured applications in Python. Chapter 8, Modules, Packages, and Libraries, Leveraging the Python Ecosystem. By now, you've learned Python's fundamental building blocks: variables, data types, control flow, functions, and even object-oriented programming. These are the tools you use to write individual pieces of code. However, no programmer works in isolation, and no one builds everything from scratch. Just as carpenters don't mill their own lumber for every project, software developers rely heavily on existing building materials. This is where Python's incredibly rich ecosystem comes into play. The ability to reuse code written by others, or to organize your own code into structured, shareable units, is fundamental to modern software development. This chapter will introduce you to modules, single Python files containing functions, classes, and variables that you can reuse elsewhere. Packages, collections of related modules organized in directories. Libraries, broad terms referring to collections of modules and packages, either built-in, standard library, or third-party. Understanding how to leverage this ecosystem will drastically increase your productivity and the complexity of the problems you can solve. 8.1 What are modules? At its simplest, a module is a single Python file, PyExtension, that contains Python code, functions, classes, variables, and executable statements. When you import a module, you gain access to all the definitions within it. Think of a module as a toolbox. Inside that toolbox are various tools, functions, classes that you can use in your main workshop, your current script. 8.1.1 Creating your own module. Let's create a simple module. Create a file named mymathpy, #mymathpy. Pi equals 3.14159. Def add xy. Returns the sum of two numbers. Return x plus y. Def subtract xy. Returns the difference of two numbers. Return xy. Create another file, named mainpy in the same directory as mymathpy. 8.1.2 Importing modules. There are several ways to import definitions from a module into your current script. Import module name. This imports the entire module. You then access its contents using modulename.itemName. Hash for print, #mainpy. #import mymath. #resulted equals mymathAdd, 10, 5. #printfSum, resulted, #output sum. 15. #printfpy from module, mymathpi, #output, pi from module, 3.14159. #resultsub equals mymathSubtract, 10, 5. #printf difference, resultsub, #output, difference, 5. Verbal explanation for audio. In mainpy, the first line is import mymath. This makes everything in mymathpy available. To use the add function, you type mymathadd then its arguments. Similarly for mymathpi to access the variable. From module name import item 1, item 2. This imports only specific items, functions, classes, variables directly into your current namespace. You can then use them without the module name. Prefix, hash for print, hash mainpi, hash from mymath import add, pi. Hash result equals add, 27. Hash print f result, hash output, result. 27. Hash print f pi, hash output, pi, 3.14159. Hash subtract, 5, 2. Hash this would cause a name error because subtract was not imported. Verbal explanation for audio. If you only need add and pi from mymath, you can say from mymath import add, pi. Now you can use add directly without mymath. If you try to use subtract, it won't be recognized because it wasn't specifically imported. From module name import, wildcard import use with caution. This imports all public items from the module directly into your current namespace. Hash for print. Hash mainpi. Hash from mymath import. Hash print add 120, hash output, 120. Hash print pi hash output, 3.14159. Verbal explanation for audio. From mymath import brings everything from mymath into your current file. Add and pi can then be used directly. Caution. While convenient, wildcard imports are generally discouraged in larger projects because they can lead to name collisions, where two different modules define items with the same name, leading to confusion about which one you're actually using, and make it harder to tell where functions variables came from. Stick to import module name or from module name import item for clarity. Import module name as alias. You can give an imported module a shorter, more convenient alias. Hash for print. Hash mainpi. Hash import mymath esm. Hash print mmadd 5010, hash output, 60. Verbal explanation for audio. You can import mymath esm for a shorter alias. Now you use mad instead of mymathadd. This is widely used for larger libraries. For example, import numpy as np. The name equals main idiom. Sometimes, a Python file can be used both as a standalone script and as a module imported by other scripts. The if name equals main block allows you to specify code that should only run when the script is executed directly, not when it's imported as a module. For print, hash mymathpi modified, pi equals 3.14159. Def add xy, return x plus y. Def subtract xy, return xy. If name equals main, print, this code runs only if mymathpi is executed directly. Hash print f5 plus 3 equals add 5, 3. Hash this will be executed. Verbal explanation for audio. In a Python file, the name variable is automatically set by Python. If the file is run directly, name is set to the string main. If the file is imported as a module, name is set to the module's name, e.g., mymath. So the if name equals main block allows you to put test code or examples that only run when you explicitly run that file. If another script imports mymath, this if block will be skipped. 8.2 Python's standard library. One of Python's greatest strengths is its comprehensive standard library. This is a vast collection of modules that come pre-installed with your Python distribution. These modules provide solutions for a wide range of common programming tasks, meaning you often don't need to install anything extra for basic functionalities. Here are a few examples of useful standard library modules. Math provides mathematical functions and constants, e.g. mathsqrt, mathsyn, mathpy. Hash for print, hash import math. Hash print mathsqrt, 25, hash output. 5.0. Hash print mathpy, hash output. 3.141592653589793. Random, for generating random numbers, e.g. random randant, random choice. Hash for print, hash import random. Hash print random randant 1, 10, hash output. A random integer between 1 and 10, inclusive. Hash fruits equals apple, banana, cherry. Hash print random choice fruits, hash output. Randomly selected fruit. Data time for working with dates and times. Hash for print, hash import data time. Hash now equals data time now. Hash print f current date and time, now. Hash print f year, now year, month. Now month. OS provides functions for interacting with the operating system, e.g., creating deleting directories, path manipulation. Hash for print, hash import OS. Hash get current working directory. Hash print f current directory. OS get could. Hash print f path separator. OS sep hash output. On Linux Mac OS / on Windows. sys provides access to system-specific parameters and functions. Useful for command line arguments and exiting programs. JSON, for working with JSON, JavaScript object notation, data, a common format for data exchange. CSV, for working with CSV, separated values, files. Exploring the Python standard library documentation is highly recommended as you progress. It's a goldmine of pre-built functionality. 8.3 packages, organizing related modules. As projects grow, having many modules in a single directory can get messy. Packages provide a way to organize related modules into a directory hierarchy. A package is essentially a directory containing a special file named init.py, which can be empty, but signals Python that the directory is a package and other modules or subpackages. Think of a package as a folder that groups related toolboxes, modules together. For print, conceptual directory structure. miproject / main.py, hash calculations, hash this is a package. Hash init.py hash makes calculations a package. Hash arithmetic.py hash module for basic math. Hash geometry.py hash module for geometry. Verbal explanation for audio. Imagine your project is a top-level folder. Inside it, you have your main script, main.py. Then, you have another folder called calculations. This calculations folder is a package if it contains a special empty file named init.py. Inside calculations, you might have other Python files like arithmetic.py and geometry.py, which are modules within the package. Importing from packages. You can import modules and items from packages using dot notation. For print, hash calculations / arithmetic.py. Def add a b, return a plus b. Hash calculations / geometry.py. Def circularia, radius. Hash import math hash can import other modules inside. Return math.py radius 2. Hash main.py. From calculations, import arithmetic. From calculations geometry, import circularia. Hash print arithmetic add 10 20, hash output 30. Hash print circularia 5, hash output 78.539816339744483. Verbal explanation for audio. To use features from a package, you specify the package name, then a dot, then the module name. For instance, from calculations import arithmetic imports the arithmetic module from the calculations package. You can then use arithmetic add. Alternatively, you can import specific functions directly, like from calculations geometry import circularia, and then use circularia directly. 8.4 libraries. Collections of functionality. The terms module, package, and library are sometimes used interchangeably, but generally, module, a single .py file. Package, a directory containing multiple modules and an init.py file. Library, a more general term referring to a collection of modules and packages that provide specific functionality. Python's standard library is one example. There are also countless third-party libraries. Finding and installing third-party libraries using pip. The true power of the Python ecosystem lies in the vast number of third-party libraries available. These are developed by the community and are usually open source. The primary source for these libraries is the Python Package Index, PyPy, a repository of over 400,000 Python packages. You install these packages using pip, the Python package installer, which we briefly introduced in Chapter 2. Remember, it's crucial to install packages within your project's virtual environment to avoid conflicts. Let's say you want to use the requests library, which is incredibly popular for making HTTP requests, e.g., fetching data from websites or APIs. Activate your virtual environment, as shown in Chapter 2. Install the package using pip install requests. Pip will download the requests library, and any packages it depends on from PyPy, and install them directly into your active virtual environment. Use the installed package in your Python script, hash for print, hash mywebscraper.py, hash import requests, hash response equals requests get, https://www.example.com. #print f status code. Response status code, #output, status code, 200 if successful. #print f content length, len response text, characters. Verbal explanation for audio. Once requests is installed in your virtual environment, you can import requests in your Python file. Then, you can use its functions like requests, get, to fetch the content of a web page. The response object returned has attributes like status code, e.g., 200 for success, and text, the actual content of the page. Managing dependencies, requirements.txt. When you work on a project, you'll install several third-party libraries. To keep track of these dependencies and to easily set up the project on another computer or for collaborators, generate a requirements.txt file after installing all necessary packages in your virtual environment. Pip freeze requirements.txt. This command lists all installed packages and their versions and saves them to a file named requirements.txt. Install dependencies from requirements.txt on a new machine or for a collaborator after activating their virtual environment. Pip install r requirements.txt. This will install all packages listed in the requirements.txt file. This systematic approach to using modules, packages, and libraries, combined with virtual environments, is the standard practice in professional Python development. It ensures your projects are organized, manageable, and reproducible. Try it yourself. Create a simple module. Create a new Python file named mutalspy. Inside mutalspy, define a function ispalindrome, text that takes a string and returns true if it's a palindrome, reads the same forwards and backwards, ignoring case and spaces, and false otherwise. Hint: you might want to convert the text to lowercase and remove spaces before checking. Add an if name = main, block to mutals, py that tests ispalindrome, with a few examples, e.g., madam, able was I ere I saw Elba. Import and use your module. In a separate file named appy in the same directory, import your mutals module. Use mutals ispalindrome to check if a word entered by the user is a palindrome. Print the result. Explore the random module, import the random module, use random randint to simulate rolling a 6-sided die. Print the result. Create a list of options, choices = rock, paper, scissors. Use random choice to randomly select one of these options and print it. Install and use a third-party library. Activate a virtual environment ** for this project. Install the Colorama library using pip. Pip install Colorama. Create a new Python file, e.g., colorfueloutput.py. In this file, import for and style from Colorama. Print some text in a different color, for example. From Colorama, import for, style. Print f4 green this text is green, style reset all. Print f4 red this text is red, style reset all. Note: stylariactll resets the color back to default. After running the script, use pip freeze requirements.txt and inspect the generated file. Understanding and actively using Python's module and package system, along with pip and virtual environments, is a hallmark of an effective Python developer. It's how you tap into the immense collaborative power of the Python community. Chapter 9: Error Handling and Debugging, Ensuring Robust and Reliable Code. As you've progressed through the previous chapters, you've undoubtedly encountered various errors. Don't worry, that's a perfectly normal and essential part of learning to code. Every programmer, from beginner to expert, faces errors regularly. The key is not to avoid them, but to understand them and develop strategies for handling them gracefully. In software development, making your code robust and reliable means it can anticipate and appropriately respond to unexpected situations without crashing. This is achieved through error handling. Additionally, when your code doesn't behave as expected, even without crashing, you need techniques to debug it, to find and fix the logical flaws. This chapter will equip you with essential skills for dealing with problems in your Python code. Understanding syntax errors versus exceptions, runtime errors. Differentiating between compile time issues and problems that occur during execution. Handling exceptions with try, except else, finally. Gracefully managing predictable errors. Raising custom exceptions, defining your own error conditions. Debugging techniques, Strategies for finding and fixing logical bugs. Basic logging. A more structured way to record program events and errors. 9.1 Understanding errors. Syntax errors versus exceptions. Python programs can fail for different reasons. It's important to distinguish between the two main categories. 9.1.1 Syntax errors, parsing errors. A syntax error occurs when you write code that Python cannot understand because it violates the language's grammar rules. These errors prevent your program from running at all. They are usually caught by the Python interpreter before any of your code is executed or by your IDE editor as you type. Common examples: missing a colon after an if statement or a function definition, mismatched parentheses or quotes, incorrect indentation, typing print hello instead of print hello for print, hash if score 90 hash missing colon, print a, hash print hello hash missing closing quote. Verbal explanation for audio. If you type if score 90 but forget the colon at the end, that's a syntax error. Or if you have an opening quote for a string but forget the closing one. Your editor usually highlights these immediately. When Python encounters a syntax error, it will typically point to the line and position where the error occurred, or where it detected the error, which might be just after the actual mistake. You need to fix these before your program can even start. 9.1.2 Exceptions, runtime errors. An exception occurs when a syntactically correct Python program encounters an error during its execution. These errors disrupt the normal flow of the program. If unhandled, an exception will cause your program to crash and display a traceback error message. Common examples: name error, trying to use a variable or function name that hasn't been defined; type error, performing an operation on values of inappropriate, e.g., trying to add a number and a string; index error, trying to access an index that is out of bounds for a list or string; key error, trying to access a non-existent key in a dictionary; zero division error, attempting to divide a number by zero; file not found error, trying to open a file that doesn't exist; for print, hash name error, print undefined variable, hash type error, print 5 plus hello, hash index error, mylist equals 1, 2, 3, print mylist 3, hash zero division error, result equals 10/0. Verbal explanation for audio. If you try to print an undefined variable that hasn't been given a value, you'll get a name error. If you try to add a number 5 to a string, hello, that's a type error. If your list has only 3 items at index 0, 1, 2, and you try to get mylist at index 3, that's an index error. Dividing 10 by 0 results in a zero division error. These are all runtime errors or exceptions. 9.2 Handling exceptions with try, except else finally. Python provides a powerful mechanism to catch and handle exceptions using try and except blocks. This allows your program to recover from errors gracefully rather than crashing. 9.2.1 The try and except block. The code that might raise an exception is placed inside the try block. If an exception occurs within the try block, the program immediately jumps to the except block. The except block specifies the type of exception to catch. You can have multiple except blocks for different exception types. Syntax. For print, try, hash code that might cause an error. Except specific error type. Hash code to run if specific error type occurs. Except another error type. Hash code to run if another error type occurs. Hash except. Hash general except block catches any other error, less specific. Hash code to run for any other error. Verbal explanation for audio. You put the risky code inside the try block. If something goes wrong there, Python immediately jumps to the except block. You can specify which specific error type you want to catch. For example, except zero division error would catch division by 0. You can have multiple except blocks for different types of errors. A bare except, without a specific error name, will catch any error, but it's generally better to catch specific errors for clarity and control. Example, for print, try. Numerator equals int, input, enter a numerator. Denominator equals int, input, enter a denominator. Result equals numerator/denominator. Except value error, print, invalid input. Please enter valid numbers. Except zero division error, print, error, cannot divide by 0. Hash except exception as e. Hash catch any other unexpected errors. Printf an unexpected error occurred, e. Else printf result. Result. Finally, print operation complete. Verbal explanation for audio. In this example, the try block attempts to get two numbers from the user and perform division. If the user enters text instead of a number, a value error occurs, and the matching except value error. Block prints invalid input. If the user enters 0 for the denominator, a zero division error occurs and except zero division error. Prints error cannot divide by 0. The except exception as e. Line is a general catch-all for any other errors, and e captures the specific error message. The else block runs only if no exception occurred in the try block, printing the result. The finally block always runs, regardless of whether an exception occurred or not, printing operation complete. 9.2.2 The else block optional. The else block in try except chains is executed only if the code inside the try block completes without raising any exceptions. It's useful for putting code that depends on the try block succeeding. 9.2.3 The finally block optional. The finally block is always executed, regardless of whether an exception occurred in the try block or not, and regardless of whether it was handled by an except block. This is often used for cleanup operations, like closing files or network connections that must happen. 9.3 Raising custom exceptions. Sometimes, you might want to stop the normal flow of your program and signal an error condition that you define yourself. You can do this using the raise keyword. This is useful when you detect a problem in your function that prevents it from performing its intended purpose. For print, hash class invalid age error, exception. Hash define a custom exception, raised when the input age is less than 0 or greater than 150. Hash pass hash custom exceptions usually just pass. Def settage age, if not this instance, age int. Raise type error, age must be an integer. If age 0 or age 150, raise invalid age error, age must be between 0 and 150. Printf age set to age. Try settage 180. Accept invalid age error as e, printf custom error, e. Accept type error as e, printf type error, e. Verbal explanation for audio. First, we define our own error type invalid age error by creating a new class that inherits from exception. We typically just put pass inside it. Then, in the setAge function, if the age is not an integer, we raise type error, age must be an integer. If the age is outside a valid range, 0 to 150, we raise invalid age error. Age must be between 0 and 150. When we call setAge 180 in a try block, it raises invalid age error, which is then caught by accept invalid age error as e, and prints our custom error message. 9.4 Debugging techniques. Error handling deals with anticipated problems. Debugging deals with bugs, logical flaws that make your program behave incorrectly, even when it doesn't crash. 9.4.1 Print, debugging. This is the most common and simplest form of debugging. You strategically place print statements throughout your code to inspect the values of variables at different points in time, confirming if the program's state is what you expect. For print def calculate average numbers, hash print f debug, input numbers, numbers, hash debug print. Total equals sum, numbers. Hash print f debug, total sum. Total, hash debug print. Average equals total / len, numbers. Return average. Data equals 10, 20, 30. AVG equals calculate average, data. Print f average, AVG. Verbal explanation for audio. To debug calculate average, you might add print statements to see debug. Input numbers and debug, total sum at different points. This helps you track the flow and values of variables. While effective for simple problems, print debugging can become cumbersome in large projects. 9.4.2 Using an IDE debugger. Modern IDEs, like VS Code or PyCharm, come with powerful integrated debuggers. These tools allow you to set breakpoints, pause program execution at specific lines, step through code, execute code line by line, inspect variables, see the current values of all variables in scope at any breakpoint, call stack, view the sequence of function calls that led to the current point. Verbal explanation for audio. Using an IDE's debugger is like pausing your program mid-execution and inspecting its internal state. You can set a breakpoint by clicking next to a line of code in most IDEs. When your program hits that line, it stops. Then you can step over to execute the next line, step into a function to go inside it, or step out to finish the current function. Simultaneously, you can watch the values of all your variables change in a separate window. This is vastly more efficient for complex issues than print statements. 9.4.3 Common Debugging Strategies. Reproduce the bug. Can you make the error happen consistently? If so, you're halfway there. Isolate the problem. Comment out sections of code or simplify input until you find the smallest possible code block that still exhibits the bug. Divide and conquer. If a large function isn't working, break it down. Verify that each smaller logical step is performing correctly. Check assumptions. Are your assumptions about variable values or function inputs correct? Read error messages carefully. Python tracebacks are full of information: file, line number, type of error. Learn to decode them. Use version control. If you use Git, which we'll introduce in Chapter 11, you can revert to previous working versions of your code. 9.5 Basic Logging Module. For professional applications, print statements are insufficient for recording program activity and errors. The logging module in Python's standard library provides a flexible and powerful way to send status messages, warnings, and error messages to various destinations: console, file, network, etc. Logging allows you to categorize messages by severity, debug, info, warning, error, critical, control where messages go, include timestamps and other contextual information automatically. For print, import logging. # basic configuration. Log messages to console. Logging basic config. Level equals logging.info. Format equals %. isktime s %. Level name s %. Message s. Def process data. If not data, logging warning. Received empty data for processing. Return 0. Try average equals some data /len data. Logging.info. F data processed successfully. Average. Return average. Except type error. Logging error. Data contains non-numeric values. Cannot calculate average. Return none. # process data 1 2 3. #info message. # process data. #warning message. # process data 1 3. #error message. Verbal explanation for audio. First, you import logging. You can configure basic logging to show messages of a certain level, like info or higher, and in a specific format. In the process data function, if the data is empty, logging warning is used to indicate a non-critical issue. If data processing succeeds, logging.info records the success. If a type error occurs, e.g., trying to sum numbers and text, logging error records a critical problem. This provides a much more robust way to track your program's behavior than simple print statements. Mastering error handling and debugging is crucial for writing reliable Python software. It's not just about fixing bugs, but about anticipating problems and designing your code to gracefully handle the unexpected. Try it yourself. Input validator with error handling. Write a program that continuously prompts the user to enter a valid positive integer. Use a try-except block to catch value error if the user enters non-integer text, e.g., ABC. Print an appropriate error message and prompt again. If the user enters an integer, check if it's positive. If it's not less or equals 0, raise a value error with a custom message, e.g., input must be a positive integer. Keep prompting until a valid positive integer is entered, then print thank you and break the loop. Safe division function. Create a function safedivide numerator denominator that handles 0 division error and type error. If denominator is 0, print error, cannot divide by 0, and return none. If numerator or denominator are not numbers, print error, both inputs must be numbers, and return none. Otherwise, return the result of the division. Test your function with valid numbers, division by 0, and non-numeric inputs. Traceback analysis. Intentionally create a name error in a simple script, e.g., print non-existent variable. Run the script and carefully read the traceback. Identify the type of error, the file where it occurred, the line number, the context, the line of code itself. Now, try to fix the error based on the traceback, logging a function call. Configure basic logging at info level. Create a function process transaction. Amount, currency, that does the following. Logs an info message when it starts processing the transaction, e.g., processing transaction for XY. If amount is negative or currency is an empty string, logs a warning message, e.g., invalid transaction details provided, and returns false. Otherwise, logs an info message like transaction successfully processed, and returns true. Call process transaction with valid and invalid inputs and observe the logged messages in your console. These exercises will provide you more practical experience with handling expected errors, detecting unexpected ones, and improving the robustness of your Python code. Chapter 10, Working with Files and Data, Storing and Retrieving Information. Up to this point, our Python programs have been largely ephemeral. Variables hold data in memory only as long as the program is running. Once the program finishes, all that data disappears. But what if you want your programs to remember things between runs? What if you need to process large amounts of data stored outside your program? This is where working with files comes in. Files provide a persistent way to store and retrieve information. Text files are common for storing readable data, while structured formats like CSV and JSON are essential for exchanging data between programs or with external services. In this chapter, we'll cover File I/O basics, how to open, read from, write to, and close text files, the with statement, a best practice for safe file handling, working with CSV files, using Python's built-in CSV module for tabular data, working with JSON data, using Python's built-in JSON module for structured, human-readable data, interacting with the file system, OS module, basic operations like checking paths and creating directories, 10.1 File I/O basics, reading and writing text files. The fundamental process for interacting with files is typically open the file, perform operations, read or write, close the file. 10.1.1 Opening files, open. The open function is used to open a file. It takes two primary arguments, the file path string and the mode string. Common modes. Read mode default, opens the file for reading. File pointer is at the beginning, raises file not found error if the file doesn't exist. Write mode, opens the file for writing, creates the file if it doesn't exist. If the file does exist, it truncates, empties the file. Append mode, opens the file for writing, creates the file if it doesn't exist. If the file exists, writing appends new content to the end of the file without obliterating existing content. Exclusive creation mode, creates a new file, raises file exists error if the file already exists. Text mode default, for text files. Binary mode, for non-text files, e.g. images, executables. We'll primarily focus on text mode, RT, WT, where the T is often omitted as it's the default. For print, ## open a file for writing, will create or overwrite. FileWrite open, notes.txt, W. ## open a file for appending. Filippend equals open, log.txt, ## open a file for reading. Fileread equals open, data.txt, R. Verbal explanation for audio. To open a file, you use the open function. The first argument is the file's name or path, such as notes.txt. The second argument is the mode. W stands for write mode. If notes.txt doesn't exist, Python creates it. If it exists, Python deletes all its previous content. Stands for append mode. If log.txt exists, new content will be added to the end. R stands for read mode. This is the default. If data.txt doesn't exist, Python will raise a file not found error. 10.1.2 Writing to files, write lines. Once a file is open in write, W, or append, a mode, you can write content to it. File write string writes a string to the file. You must explicitly add newline characters, \n, if you want text on new lines. File write lines iterable off strings. Writes all strings from an iterable, like a list of strings, to the file. Again, you need to add \n yourself if desired. For print, filiobj equals open, mydocument.txt, W. Filiobj, this is the first line, \n. Filiobj, and this is the second line, \n. #filiobj close, # important to close. Verbal explanation for audio. To write to a file, first open it in write mode. Then, use the write method on the file object. For example, filiobj-write, this is the first line, \n. Notice the \n at the end, which puts the next content on a new line. Remember to close the file after writing. 10.1.3 Reading from files. Readline, readlines. Once a file is open in read mode, you can read content from it. File read size reads at most size bytes. If size is omitted or negative, reads the entire content of the file, returns content as a single string. File readline reads a single line from the file. File readlines reads all lines from the file and returns them as a list of strings, where each string is a line. Each line string typically includes the newline character \n at the end. For print, ## assume mydata.txt contains ##line 1, apple, ## line 2, banana, ## line 3, cherry, ## read entire file. Filiobj equals open, mydata.txt, r, content equals filiobj read. Print content, filiobj close, ## read line by line. Filiobj equals open, mydata.txt, r, line 1 equals filiobj readline. Line 2 equals filiobj readline. #print line 1 strip, #strip, removes leading trailing whitespace including newline. Print line 2 strip, filiobj close, ## read all lines into a list. Filiobj equals open, mydata.txt, r, all lines equals filiobj readlines. For line in all lines, print line strip, filiobj close. Verbal explanation for audio. To read the entire content of a file into one long string, use the read method. To read one line at a time, use readline. To read all lines into a list of strings, where each string is a line from the file, use readlines. A common trick is to use strip on each line to remove any extra spaces or the newline character at the end. 10.1.4 Closing files. Close. It is crucial to close files after you are done with them. If you don't close a file, changes might not be saved, or the file might remain locked and inaccessible to other programs. 10.2 The with statement. Automatic resource management. Manually opening and closing files can be error-prone. What if your program crashes or an exception occurs before file close is called? The file might remain open. Python's with statement, also known as a context manager, provides a much safer and more convenient way to handle file operations. It automatically ensures that files are properly closed, even if errors occur. Syntax for with statement. For print, with open mydocument.txt, w as filiobj-write, this line is written using with \n. ## file is automatically closed here, outside the with block. Verbal explanation for audio. Instead of filiobj equals open, you use with open mydocument.txt, w as filiobj. Any code indented under the with statement can use filiobj. When the indented block finishes, either normally or due to an error, Python automatically closes the file object for you. This is the recommended way to handle files. 10.3 Working with CSV files. CSV, separated values. Files are plain text files used to store tabular data organized in rows and columns. Each line in the file represents a row, and columns are separated by a delimiter, most commonly a comma. Python has a built-in CSV module specifically designed for working with CSV files, handling the complexities of quoting, commas within fields, etc. 10.3.1 Writing to CSV files. For print, import CSV. Data equals name, age, city. Alice, 30, New York. Bob, 24, London. Charlie, 35, Paris. # with open, people CSV, w newline equals, as CSV file. #newline equals is important for CSV. Writer equals CSV writer, CSV file. Writer writros, data. Print, people CSV created. Verbal explanation for audio. First, import CSV. Then, prepare your data as a list of lists, where each inner list is a row. Open your CSV file in write mode using a with statement. Crucially, specify newline equals in the open function call. This prevents extra blank rows. Create a CSV writer object from your file object. Use writer writros, data, to write all your rows. 10.3.2 Reading from CSV files. For print, import CSV. With open, people CSV, R, newline equals, SCSV file, reader equals CSV reader, CSV file. For row and reader, print row. # output, # name, age, city, # Alice, 30, New York, # Bob, 24, London, # Charlie, 35, Paris, ##. It's often useful to read into a list of dictionaries for easier access. With open, people CSV, R, newline equals, SCSV file, # reader equals CSV dict reader, CSV file, # reads first row as headers. For row and reader, print row name, row age, # output, # Alice 30, # Bob 24, # Charlie 35. Verbal explanation for audio. To read, import CSV, then open the file in read mode with newline equals. Create a CSV reader object. You can then loop directly over this reader object, and each row will be a list of strings representing the columns. For even easier access, use CSV dict reader. This treats the first row as headers and allows you to access data by column name, like dictionary keys, such as row name. 10.4 Working with JSON data. JSON, JavaScript Object Notation, is a lightweight data interchange format. It's human-readable and easy for machines to parse and generate. JSON is very common for configuration files, data storage, and especially for exchanging data between web applications and servers, APIs. JSON data is structured using key-value pairs, like Python dictionaries, and ordered lists of values, like Python lists. Python has a built-in JSON module to handle JSON data. 10.4.1 Writing, dumping, Python data to JSON. The JSON dump function writes Python objects like dictionaries and lists to a JSON file. JSON dumps converts a Python object to a JSON formatted string. For print, import JSON. Person data equals name, Alice Wonderland, age, 30, student, false, courses, math, physics, address, street, 123, rabbit hole, city, Wonderland. With open, person JSON, W as JSON file, # JSON dump, person data, JSON file, indent equals 4 # indent for pretty printing, # to get JSON string directly. JSON string equals JSON dumps, person data, indent equals 4. Print JSON string. Verbal explanation for audio. First, import JSON. Prepare your Python data, which is typically a dictionary or a list containing other dictionaries or lists. Open a file in write mode using with. Then, JSON dump takes your Python data object and the file object. The optional indent equals 4 argument makes the JSON output more readable by indenting it. If you just want the JSON data as a string, not writing to a file, use JSON dumps. Dumps with safer string. 10.4.2 Reading, loading, JSON data from files. The JSON load function reads JSON data from a file and converts it into Python objects, dictionaries, lists, etc. JSON loads converts a JSON formatted string into a Python object. For print, import JSON. With open, person JSON, R as JSON file. Loaded person data equals JSON load, JSON file. # print loaded person data name, # output. Alice Wonderland. # print loaded person data address, # output, Wonderland. # to load from JSON string directly, JSON string example equals, product, laptop, price, 1200. Loaded from string equals JSON loads, JSON string example. # print loaded from string product, # output, laptop. Verbal explanation for audio. To load JSON from a file, import JSON, then open the file in read mode with. Then, JSON load takes the file object and returns your Python data. You can then access it like a normal Python dictionary. If your JSON data is already in a Python string, use JSON loads. Loads within safer string to convert it to a Python object. 10.5 Interacting with the file system, OS module. The OS module in Python's standard library provides functions for interacting with the operating system, including tasks related to file paths and directories. OS path exists, path returns true if path exists, false otherwise. OS path is file path returns true if path is an existing regular file. OS path is dir, path returns true if path is an existing directory. os mkdir path creates a directory, raises file exists error if directory already exists. os makedir's path creates a directory and any necessary intermediate subdirectories. os remove path deletes a file. osrmdir path deletes an empty directory. os listdir path returns a list of all entries, files, and directories in a given path. For print, import os. # check if a file exists. If os path exists, mydocument.txt. Print mydocument.txt exists. # create a directory. If not os path exists, new folder. osmkdir, new folder. Print new folder created. # create nested directories. os makedir's, parent folder / child folder, existstock equals true. Print parent folder / child folder ensured. # list contents of current directory. Print os listdir. Verbal explanation for audio. os path exists, mydocument.txt checks if that file or folder exists. osmkdir, new folder, creates a single folder. Use os makedir's. Parent / child, existstock equals true to create nested folders and prevent errors if they already exist. os listdir will list everything in your current directory. Working with files and structured data is a cornerstone of almost any practical software application. These skills allow your programs to store information, retrieve it later, and communicate with other systems. Try it yourself. Simple to-do list text file. Create a text file called to-do.txt. Write a Python program that does the following. Add task. Asks the user for a new task and appends it to to-do.txt, each task on a new line. Use the with statement. View tasks. Reads and prints all tasks from to-do.txt. Use the with statement and read line, or a for loop over the file object. Implement these as functions, e.g. add task, view tasks. Provide a simple menu from which the user can choose to add or view. Product catalog CSV file. Define a list of lists representing fictional products. Products equals ID, name, price, 1 laptop 1200, 2 mouse 25, 3 keyboard 75. Write this data to a CSV file named product CSV using CSV writros. Now, read the product CSV file using CSV dict reader and print the name and price of each product. User profile JSON file. Create a Python dictionary representing a user profile, e.g., user profile equals username, coderx, email, coder@example.com, preferences, dark mode, notifications. Write this dictionary to a JSON file named userprofile.json using JSON dump, with indent equals 4. Now, read the userprofile.json file back into a Python dictionary using JSON load, and print the user's username and their preferences. Directory Manager, Advanced OS module, ask the user for a new directory name. Use ospath exists to check if the directory already exists. If it doesn't exist, create it using osmkdir and print directory created. If it does exist, print directory already exists. After creation, use os listdir to list the contents of the newly created directory, which should be empty. These practical exercises will strengthen your ability to manage persistent data, a crucial skill for building complete applications. Chapter 11, Building Practical Applications. From command line to web basics, Project Spotlight. Throughout the previous chapters, you've acquired a solid foundation in Python programming. Its syntax, data structures, control flow, functions, object-oriented concepts, modularity, error handling, and file operations. You've learned the individual pieces of the puzzle. Now, it's time to start putting them together to build truly practical applications. This chapter shifts our focus from understanding concepts in isolation to integrating them into cohesive projects. We'll explore how to plan a simple project, break down a problem into manageable steps, build a command line interface, CLI tool, create an interactive application that runs directly in your terminal, interact with web APIs, fetch data from external web services, a fundamental skill for modern applications. Introduce version control, Git. Understand the basics of tracking changes in your code, essential for collaborative and organized development. Our goal will be to create a simple yet functional quote of the day application, which will enhance throughout the chapter. 11.1 Project Planning, breaking down the problem. Before writing any code, a good developer always starts with a plan. This helps clarify objectives, identify necessary features, and anticipate challenges. For our quote of the day application, let's consider the requirements. Core functionality. The program should display a random quote. User experience. Allow the user to favorite quotes so they can be saved. Allow the user to view their favorited quotes. Provide a clear command line interface, CLI for interaction. Data storage. Favorited quotes need to be saved persistently. Quote source. Where do the quotes come from? We'll use a public web API for this. Breaking it down into modules, high-level plan, quotes or SPY. Handles fetching quotes from the external API. Storage Py handles saving and loading favorited quotes from a file, e.g. JSON. CliPy manages the command line interface and user interaction. MainPy, the entry point of our application, orchestrating the different modules. This modular approach ensures each part of our application has a clear responsibility, making it easier to develop, test, and maintain. 11.2 Building a command line interface, CLI tool. A CLI tool is a program that you interact with primarily through text commands in your terminal, command, prompt, PowerShell, Bash, etc. Many powerful tools like Git, pip, or even ls/dir are CLI tools. For our quote of the day app, we need to allow the user to choose actions like get a new quote, favorite the current quote, or view favorites. We'll build a simple menu system. Let's start by creating mainpy to handle the basic user interaction loop. For print, #mainpy. Def display menu prints the main menu options to the console. Print \n quote of the day app. Print 1. Get a new random quote. Print 2. Favorite current quote, not yet implemented. Print 3. View favorited quotes, not yet implemented. Print 4. Exit. Print def run app. Main function to run the quote of the day application. While true, display menu. Choice equals input. Enter your choice 1 to 4. If choice equals 1, print \n getting a new quote. #placeholder for getting quote. Print placeholder. A wise man once said. #in future. Get quote from quote source module. Elif choice equals 2. Print feature coming soon. Elif choice equals 3. Print feature coming soon. Elif choice equals 4. Print exiting application. Goodbye. Break #exit the while loop. Else print invalid choice. Please enter a number between 1 and 4. If name equals main. Run app. Verbal explanation for audio. Open your mainpy file. We define a function display menu that simply prints options like get new quote, favorite quote, etc. The run app function contains our main loop. It uses a while true loop to keep running until the user decides to exit. Inside the loop, it first calls display menu to show the options. Then, input asks the user for their choice. We use if-else statements to respond to the user's input. If choice is 1, we'll print a placeholder message. For 4, we break the loop to exit the program. Invalid choices show an error. Finally, the if name equals main block ensures that run app is called when the script is executed directly. Run this mainpy script from your terminal Python mainpy, and you'll see a basic interactive menu. You've just built your first interactive CLI. 11.3 Interacting with Web APIs. Our application needs quotes. Instead of hard-coding them, we'll fetch them from a public API, Application Programming Interface. An API is a set of rules and protocols by which different software components communicate. Many online services expose APIs that allow you to programmatically access their data and functionality. For our quotes, we'll use a simple public API like https api.quotable.io/random. This API returns a random quote in JSON format. To interact with web APIs effectively in Python, the requests library is the de facto standard. It simplifies making HTTP requests. Activate your virtual environment. Install requests. Pip install requests. Create quotes or SPY, for print, ## quotes or SPY. #import requests. #def get random quote. Fetches a random quote from the quotable API. #try. #response equals requests get. https api.quotable.io/random. Hash response raise status. Hash raises HTTP error for bad responses, for XX or 5XX. Hash data equals response JSON. Hash parse JSON response. Hash return. Hash content. Data content. Hash author, data author. Hash tags, data get. Tags, hash use get for optional keys. Hash id, data ID, hash unique ID for the quote. Hash. Hash accept requests exceptions. Request exception as E. Hash print F error fetching quote, E. Hash return none. Hash accept key error as E. Hash print F error parsing quote data missing key, E. API response might have changed. Hash return none. Hash if name equals main. Hash quote equals get random quote. Hash if quote, hash print F quote, backslash quote content backslash, quote author. Hash print FID, quote id. Verbal explanation for audio. In quotes or spy, we import requests. The getRandom quote function does the heavy lifting. Inside a try block, it makes a GET request to the API URL using requests get response raise for status. Checks if the request was successful. If not, it raises an error. Response JSON parses the JSON content from the response into a Python dictionary. We then extract content, author, tags, and id from this dictionary. We use get for tags in case the API response doesn't always include them. If anything goes wrong during the request, like no internet connection, a request's exceptions, request exception is caught. If the JSON structure is unexpected, a key error is caught. Now, integrate this into MainPy. For print MainPy modification, hash hash, display menu function remains the same. Hash hash import new modules. Import quotesers. Hash hash import storage hash, we'll add this later. Def run app, main function to run the quote of the day application. Hash current quote equals none hash to store the quote currently being displayed. While true, display menu. Choice equals input, enter your choice 1 to 4. If choice equals 1, print backslash n getting a new quote. New quote equals quotesers get random quote. If new quote, current quote equals new quote hash store the fetch quote. Print f n quote. Backslash current quote content backslash. Print f author, current quote author. Else print could not fetch a quote at this time. Elif choice equals 2, if current quote. Print favoriting feature will save this quote. Print f backslash current quote content backslash, current quote author. Hash in future, call storage save quote, current quote. Else, print no quote to favorite, get a new quote first. Elif choice equals 3, print viewing favorites feature coming soon. Hash in future, call storage load quotes. Elif choice equals 4, print exiting application, goodbye. Break, else print invalid choice. Please enter a number between 1 and 4. If name equals main, run app. Verbal explanation for audio. In MainPy, we add import quote source at the top. Inside run app, we initialize current quote to none. When the user chooses 1, we call quote source get random quote. If a quote is successfully returned, we store it in current quote and print its content and author. If not, we print an error. For option 2, favoriting, we add logic to check if current quote is not none before we attempt to favorite. Empty favorite and view favorite sections are clearly marked for future implementation. 11.4 Introduction to Version Control Git. As soon as you start working on any project that is more than a single throwaway script, you need a way to track changes. What if you introduce a bug and want to revert to a previous working version? What if you want to experiment with a new feature without breaking the main application? What if you want to collaborate with others? Version control systems, VCS, like Git solve these problems. Git is a powerful tool that allows you to track changes, record every modification to your code over time, revert to previous versions, easily go back to an earlier stable state, branch and merge, experiment with new features in isolation without affecting the main codebase, then seamlessly bring them back. Collaborate. Work on the same project with multiple people without overwriting each other's work. Git is so integral to modern development that understanding its basics is now a fundamental skill. 11.4.1 Basic Git Workflow. Initialize a repository, Git init. From your project's root directory in the terminal, initialize a new Git repository. This creates a hidden Git folder that tracks your project's history. cd microtap hash assuming this is your project folder. Git init. Hash output, initialized empty Git repository in Git. Verbal explanation for audio. First, use your terminal to change directory into your project folder. Then, type git init. This command sets up Git in your folder. Check status, Git status, see what changes Git is aware of. Git status. Hash output. Hash untracked files. Hash use git add file to include in what will be committed. Hash mainpy. Hash quotes by. Verbal explanation for audio. Type git status. Git will tell you which files are new or modified. In our case, mainpy and quotesourcepy are showing as untracked, meaning Git knows they exist but isn't yet tracking their changes. Stage changes, git add. Tell Git which changes you want to include in the next snapshot, commit. Git add mainpy quotesourcepy. Hash or to add all new modified files. Hash git add. Verbal explanation for audio. To tell Git you want to save the changes in mainpy and quotesourcepy, you stage them using git add mainpy quotesourcepy. You can also stage all files with git add. Commit changes, git commit. Save the staged changes as a new version in your project's history, along with a descriptive message. Git commit m, initial commit of quote app with basic CLI and API fetching. Hash output master root commit, 2 files changed, insertions plus. Verbal explanation for audio. After staging, you commit the changes with git commit m, your descriptive message here. The m flag lets you add a message that describes what changes you made in this commit. Good commit messages are very important for understanding your project's history. View history, git log, see your project's commit history. Git log. Verbal explanation for audio. Git log shows you a list of all your commits, with details like who made them, when, and the commit message. This simple cycle of modify, add, commit is the core of using Git. While Git can do much more, like branching, merging, and working with remote repositories like GitHub, which are central to collaboration, these fundamental commands are your starting point. Building practical applications forces you to integrate all the concepts you've learned. It fosters problem-solving skills and provides a sense of accomplishment by seeing your code come alive. Try it yourself. Implement storage for favorites. Create a new Python file named storagepy. In storagepy, implement 2 functions. Save quote tofel, quote, file name equals favorites.json. Takes a quote dictionary, as returned by getrandom quote, and appends it to a JSON file. Ensure you load existing favorites, append the new one, and then save the entire list back. Use JSON dump with indent equals 4. Handle file not found error if the file doesn't exist yet, start with an empty list. Load quotes from file name equals favorites.json. Loads all favorited quotes from the JSON file and returns them as a list of dictionaries. Handle file not found error, return an empty list if file doesn't exist. Remember to use with open for file operations. Integrate storage into mainpy, modify mainpy to import your storage module. In runapp, for choice equals 2, favorite current quote, call storage save quote tofel current quote. Add a print statement confirming the quote was favorited. For choice equals 3, view favorited quotes. Call storage load quotes from fail. If there are favorited quotes, loop through them and print each one neatly, e.g., quote, author. If no favorites, print a message indicating so. Practice Git. After completing the storage and integration, save all your changes. In your terminal inside the project folder, run git status to see your modified files. Your mainpy and storagepy should show as modified or untracked. Use git add to stage all changes. Use git commit m feature, implemented quote favoriting and viewing to save your progress. Open mainpy and remove or comment out the print statements that say feature coming soon. Save. Run git status again. Notice mainpy is modified. Commit this change with a message like refactor, remove coming soon messages. Run git log to see your recent commit history. Experiment with pressing Q to exit the log view. This chapter and its exercises illustrate the iterative nature of software development. You start with a plan, build features step by step, and use tools like Git to manage the process. You're now truly building applications. Chapter 12, Best Practices and Next Steps, Writing Production-Ready Code and Beyond. Congratulations! You've come a long way from hello, world. You've learned the core syntax, essential data structures, control flow, functions, object-oriented programming, how to manage modules and packages, handle errors, persistent data, and even built a small application with a command line interface, integrating with web services and using Git. This provides a robust foundation for your journey into Python software development. But while your code now works, simply getting it to function is only part of the story. Professional software development also emphasizes writing code that is readable, easy for others and your future self to understand, maintainable, easy to fix bugs, add new features, or refactor, scalable, can handle increased load or complexity, reliable, works as expected, even under unexpected conditions, as discussed in error handling, testable, can be verified for correctness. In this chapter, we'll discuss best practices that help achieve these qualities, and then look ahead at the myriad paths you can take further in your Python development journey. 12.1. Writing clean, readable, and maintainable code. Good code is like good prose, clear, concise, and easy to follow. 12.1.1 Follow PEP 8. Python Style Guide. PEP 8, Python Enhancement Proposal 8, is the official style guide for Python code. Adhering to it makes your code consistent with the vast majority of Python projects, making it easier for other Python developers to read and understand. Key aspects include indentation. Always use 4 spaces per indentation level. Your IDE editor should be configured for this. Line length. Max 79 characters per line, 88 characters for black formatter. This makes code easier to read on various screens and in side-by-side comparisons. Blank lines. Use 2 blank lines to separate top-level function or class definitions. Use 1 blank line to separate methods within a class. Naming conventions, variables and functions, snake case all lowercase, words separated by underscores. Examples, myVariable calculata total. Classes, camel case first letter of each word capitalized, no underscores. Example, my class shopping cart. Constants, ALLCAPSSNAKCSE. Example, MAXSIZDEFAULTTMUT. Whitespace, use spaces around operators equals, plus, equals, etc., after commas and around arguments for clarity, e.g., a equals b plus c, my function, arg1, arg2. Imports, each import on a separate line, grouped by type, standard library, third-party, local modules. Verbal explanation for audio. PEP 8 is like the grammar and style rules for writing Python. It specifies things like always use 4 spaces for indentation, keep lines short, use blank lines between functions for readability, and use snake case for variables and functions like myVariable, but camel case for classes like myClass. Following these rules makes your code look familiar and easier to read for anyone experienced in Python. Many IDEs and text editors have built-in support or extensions, linters like Flake 8, formatters like Black, that can automatically check and even fix your code to conform to PEP 8. 12.1.2 Meaningful names. Use descriptive names for variables, functions, and classes. Avoid single-letter variable names, unless it's a loop counter like I or J in a very small loop, abbreviations, or overly generic terms. Bad, x equals 10 proc a b, data. Good, userage equals 10, process order item list, quantity, customer records. 12.1.3 Comments and docstrings, revisited. As discussed in Chapter 6, comments for clarifying complex logic and docstrings for explaining functions and classes are vital. Comments hash explain why a particular piece of code exists or how a non-obvious part works. Don't simply reiterate what the code does, x equals 5 hash set x to 5. Focus on the intent. Docstrings describe the purpose of a function, its parameters, what it returns, and any exceptions it might raise. This serves as built-in documentation. 12.1.4 Write modular and reusable code. Functions, Chapter 6. Break down large problems into smaller, focused functions, each performing a single, well-defined task. Classes, Chapter 7. Use classes when you need to group related data attributes and behaviors methods together to represent real-world objects or concepts. Modules and packages, Chapter 8. Organize your code into logical modules and packages to improve structure and reusability across different parts of your application or even different projects. 12.1.5 Fail fast and handle errors gracefully. Validate input early. Check user input or function arguments at the beginning to catch invalid data as soon as possible. Specific exception handling, Chapter 9. Use try-except blocks to anticipate and handle specific errors gracefully, preventing your program from crashing. Avoid generic except blocks unless absolutely necessary, as they can mask unexpected issues. Logging, Chapter 9. Use the logging module for reporting events, warnings, and errors in a structured way, rather than just print statements. 12.2 Testing your code, conceptual. How do you know your code works correctly? Manual testing, running your program and checking outputs, is helpful but insufficient for anything beyond trivial applications. As your program grows, you need automated tests. Automated testing involves writing bits of code that verify other parts of your code. If you make a change, you can run your tests, and if any fail, you know you've introduced a bug or broken existing functionality. Unit tests. Test the smallest testable parts of an application, typically individual functions or methods of a class, in isolation. Integration tests. Verify that different modules or services used together, e.g., your code interacting with a database or an external API, work correctly as a combined unit. Python has built-in testing frameworks, like Unitest, and popular third-party ones, like PyTest. While diving deep into testing is beyond the scope of this foundational book, understand that testing is a crucial part of professional software development. Most professional roles will expect a basic understanding of writing and running tests. Verbal explanation for audio. Automated testing means writing separate bits of Python code to check if your main code works as expected. Imagine you have a function that calculates an average. A unit test for this function would call it with known inputs, like numbers 1, 2, 3, and then assert that the output it returns is exactly what you expect, too. If you later change the function, and it produces a different, incorrect average, the test will fail and tell you immediately. This saves a lot of manual checking and ensures your code remains reliable as you make changes. 12.3 What's next? Your journey beyond the basics. You've built a strong foundation in Python for software development. This is not the end of your learning journey, but rather a launchpad for countless exciting possibilities. Here are some popular areas where Python excels, along with resources for further exploration. 12.3.1 Web development. Backend web frameworks, Django, a high-level, full-stack web framework that encourages rapid development and clean, pragmatic design. It includes an ORM, object relational mapper, admin interface, and more batteries included features. Great for complex, database-driven applications. Flask, a lightweight micro-web framework. It provides just the essentials, allowing you to choose and integrate other libraries as needed. Great for smaller APIs or learning web concepts without a lot of overhead. Fast API, a modern, fast, high-performance web framework for building APIs based on standard Python type hints. Learning resources. Official documentation, djangoproject.com, flask.palettesprojects.com, online courses, books specific to these frameworks. 12.3.2 Data science, machine learning, and artificial intelligence. Python is the dominant language in these fields due to its extensive libraries and active community. NumPy, fundamental package for numerical computing with Python, providing powerful n-dimensional array objects. Pandas, data manipulation and analysis library, offering data frames, spreadsheet-like data structures for easy handling of tabular data. Matplotlib/Seaborn, libraries for creating static, interactive, and animated visualizations in Python. Scikit-learn, simple and efficient tools for predictive data analysis and machine learning, classification, regression, clustering, etc. TensorFlow/PyTorch, open-source machine learning frameworks for advanced deep learning tasks. Learning resources, Kaggle for datasets and competitions, Coursera, Udacity, university courses, specific books on data science with Python. 12.3.3 Automation and scripting. Python is an excellent choice for automating repetitive tasks, system administration, and network programming. OS and sys modules, standard library, for interacting with the operating system and system-specific parameters. Subprocess module, for running external commands and programs. Shuttle module, for high-level file operations, copy, move, delete. Beautiful Soup scrapey, for web scraping, extracting data from websites. Paramico, for SSH, secure shell, client and server functionality, e.g., automating tasks on remote servers. Learning resources. Automate the boring stuff with Python, a popular book course, specific courses on DevOps or scripting. 12.3.4 Desktop applications, GUI. While less prominent than web development, Python can be used to build graphical user interfaces. tkinter, Python's standard GUI toolkit, simple and usually included with Python. PyQt/PySide, powerful and feature-rich cross-platform GUI toolkits. Kivy, for developing multi-touch applications for a wide range of devices, e.g., mobile apps. Learning resources, documentation for each toolkit, specific GUI programming books. 12.4 Continuing your learning journey. The world of software development is constantly evolving. To thrive, you need to cultivate a mindset of continuous learning. Read official documentation. Python's documentation is incredibly well written. The same goes for popular libraries, Django, Flask, Pandas, etc. Join communities, Stack Overflow, a Q&A site where you can ask questions and find answers to almost any programming problem. GitHub, explore open-source projects, learn from other people's code, and even contribute. Local meetups and online forums, connect with other developers in your area or online. Build projects. The best way to learn is by doing. Start small, build something useful to you, and don't be afraid to experiment and break things. Contribute to open source. Once you're comfortable, contributing to an open source project is an excellent way to gain real-world experience and collaborate. Stay curious. Follow programming blogs, podcasts, and news to stay updated on new technologies and best practices. You now have the fundamental knowledge and tools to embark on a fulfilling and dynamic career, or hobby, in Python software development. The path ahead is challenging but equally rewarding. Embrace it.